Hello everyone, good morning. How are you guys doing?
Hello, Azeez, can you hear me?
Yes, I can hear you. Good morning.
On.
Good evening.
Right, good
Uh,
evening.
Azeez, I try to
You are
complete
your line is breaking up. I can't
your
really hear you.
the Kubernetes AWS project
I can't
and
hear you. Your line
I
is breaking up.
completed it successfully. Uh, I don't know what's the problem. Uh,
Hamza, I can't
I
hear you. Your
have
line
a
is breaking up.
question and I want to discuss it with you.
So you guys can hear me. I'm not speaking now. Now I'm speaking. Can you guys hear me now?
Yes, I can hear you.
Okay, cool. Thank you. Okay. All right. Yeah, I think it's 11:02. We're just gonna wait like maybe like till 11:05 and we can just start. Because we have a lot of stuff to cover. And um because we might not be here next week because of Christmas, so we'll see. Christmas is Thursday, right? Thursday, yeah. So yes, probably we'll probably just not but then I'll leave it up to you guys because then so Christmas is Thursday. Okay. Yeah, we can do the week after, which is the third. Right. So it's New Year. So by New Year we should all be done with all the holiday festivities. So we might probably just take off next week so you guys can enjoy your Christmas and we'll just resume January 3rd. So today we'll just try to get as much done as we can. Um, Let me share my screen. I think Hamza dropped. Yeah, I don't think his connection was good. Good morning, John. How are you? Is Juliet here? Good morning, Juliet, if you are here. Is everyone here? Because we're about to start.
Morning.
Good morning. Okay. Um, okay. Good morning, Juliet. Or good evening.
Morning, Azeez. Good morning, everyone.
Yeah, good morning. It's all right. Okay. I'm waiting for Hamza to join so I can answer his question before we start because I don't want to, because it seems like he has like a different question. Oh, I think his network is not really good. It's showing it's showing joining, but it's not really joining. All right. In the meantime, you guys can just open your you guys can open your project folder if you're following along. And if you know, you can just watch. So, all right, Hamza, can you hear me? Let me see whether he's here. Just a second, guys. Bear with me. What's going on today? Okay, it's 11:05, so I can't hear from him. So let's just start. All right. Okay. So last week we pretty much have done all the necessary things we need to do. So now today we are going to start building our resources. So the first resource we are going to build is the VPC, because that's pretty much the foundation. We'll build the VPC, then we'll just build the same way we created those resources when we completed it in the management console. It's the same thing we are going to do now. So the first thing we are going to do is in the reference file that I gave you guys, you are going to go in that variables file. So you can open that variables file and you can copy all the variables under the VPC. So the VPC is here. So just copy all the variables under the VPC. So that's from line 22 to 56. So we'll copy this variable and we will paste it in the variables file. We'll paste it in the variables file. Yeah. Right. So here, once you paste it in the variables file, remember variables is just something you make up, right? If we have to create our variables and create all the resources as we go, it is going to take a lot of time. So that's why I've already just prepared it for you. So whatever format you see how I created the variables here, that's pretty much, if you're trying to create any type of variable, that's like the standard to create a variable. And remember what I said in the variable, you can have pretty much, if you don't want to have description or type in there, you can remove it. It will still work. But for variables, you need to have just variable and the name and the 2 bracket. That's the minimum it requires you to have. So for the VPC, this is the variables we are going to use. And the variables are just like the CIDR block for the VPC, the CIDR block for the public subnets, and the CIDR block for the private subnets. So that's what these variables will give us, right? So in this variables file, we can fill this type out now. For the type of value this variable is going to expect the users to put. Like, so when we are using this variable, the type means what type of value is it going to expect. The value is going to be a string, just like the other one. And remember what I said, a string is anything that is wrapped in quote like that. So if something is wrapped in quote, that makes it a string. It's just like a word, right? So for each of these variables, starting on like line 26, we are just going to type string there. String. We are going to do the same thing on line 31. I really don't like how that auto thing is always popping in. string. I'm going to type string here. Line 36 is also going to be a string. Line 41 is also going to be a string. Line 46 is also going to be a string. Line 51, string. And line 56, string. So that's all we need to do. This variable, I'm just going to close it now. So that's all we need to do for our variables for the VPC, right? And we will reference these variables as we build our VPC. So you guys will see how it is being used. Then the next thing we are going to do is in our VPC file, we are going to open the reference for the VPC. So the reference for the VPC is here. Open it. So once you open that reference file for the VPC, copy everything there. I'm going to select everything and copy it. And I'm going to place it in my VPC file. So the VPC file that we created last week here. Or if you don't have the VPC file, you can just create it, right? So in your project, next project where you have all this file, you can right click in there, create a new, so right here. So on this next app, I can right click on it and I'll click new file, right? Then you give the file a name. You can call the file vpc.tf, right? Once you give it a name, then you paste whatever I have in the reference file there. Or you can drag the reference file in that directory yourself. It's going to be the same thing. And the thing is, the name you give these files can be any name. So you can call it any name you want. The name is just so when you look at it, you know what type of resources are there, right? So you can give it any name you want. All right, let's start. So we'll scroll up to the top of this VPC. Remember I told you guys last week, that's part of what you guys are supposed to be familiar with by today, that for any resource block you guys see me put here, you can pretty much find the documentation for it. Remember I said if you copy this, paste it in Google, it will take you directly to the documentation. And if you are trying to figure out what settings we are including here, this is based on the same settings you picked when you were deploying this in the management console. And in the documentation, if you look in the documentation under the argument section, you'll find these settings there. So anything you see is literally in the documentation. But I have to do it this way because if we have to start picking everything as we go, we are going to be here for months. So it's better to just have it this way. All right. So for our VPC, the resource type name that Terraform gives you, that if you are trying to create a VPC, this is what you must have for the resource type. And this resource block in my Terraform script, you have to give it a name to, and the name you can call it anything you want. So this reference name here is what I am giving this resource block. And this reference name allows me to reference this resource block throughout my code. And you guys will see that when we start creating other resources. So here we are going to create the VPC, and the first thing it is asking us for is we have to enter the CIDR block for the VPC. So let me move this to the side here, and I'm going to close this like this. For the CIDR block for the VPC, we created a variable for it here that we call VPC CIDR. So all you have to do is copy that variable name. You can copy it or you can type it. I always like copy pasting so that way I don't make mistakes. So we'll call it var. To reference that variable, we'll type var dot the name of that variable, which is the VPC CIDR. Then the next thing we are going to enter is the instance tenancy. Like that is what when you are creating the VPC, that option is there. So for the tenancy, always use default. So we are going to type default here. And please mind you, the default is a lowercase d. When you are working with Terraform, everything will be in lowercase. So you shouldn't, with the exception of when we get there, I'll show you guys, but when you are working with your Terraform code, everything will be in lowercase. So default, when you type out default, lowercase. Then the next setting is enabling DNS hostname. Remember when we created our VPC, we enabled the DNS hostname. For this value, what Terraform expects is a Boolean. And you will see all these things in the documentation, which is a Boolean means that it is expecting whether it is true or false. So since we are going to enable the DNS hostname, that value will be true. So type true in there. And under tags, this is where we'll give it a name, right? We'll give tag our VPC. So there's something I want to show you guys how to, that you guys will see throughout your code. High wisdom. So there's something you guys will see throughout your code is, since we are trying to tag this VPC, we can do something like this. So we have a double quote and we'll have a $sign. Where's my $sign? We have a $sign. Then we are going to have a bracket. Then in that bracket, we can just reference our environment, right? So since this is how we want to tag our resource, so we'll type var dot the environment. Our environment variable is here because remember it's what we created last week. So we type var dot environment. So we type environment here. Or you can copy it from here. Then outside of that bracket, we are going to add a hyphen and we can now type VPC. So this just means that, and you can do multiple of this $sign bracket thing here. What this will do is when we are creating the environment, when we are tagging the VPC, it is going to take whatever the value is for environment, put it in there, and it's going to add the hyphen VPC. So for example, since the value of our environment is dev, when the VPC gets tagged, this value will be dev VPC. So that's how that works. And you can do as many of these bracket thing as you want. So you can even do this dollar bracket thing and say project name. So it could be var environment hyphen bracket project name hyphen VPC. So that will give you dev nest VPC. You'll see that a lot throughout the code, especially when you guys start working. So I just wanted to include that so you guys see what it looks like. All right, so that's all we need to do to create the VPC. Once we create the VPC, the next resource we are going to create is the internet gateway, right? So you guys can see here, this is the resource type to create an internet gateway. This is the reference name we are giving this resource block within our Terraform code. And for the first argument here, it is asking what VPC do we want to attach it to? Remember when we created our internet gateway, we had to attach it to a VPC. So that's what this is saying. And if you look in the argument name, it will be very descriptive. So here it is saying VPC ID, meaning that the ID of the VPC you want to attach it to. The VPC we want to attach it to is the VPC we created up here. So to reference this VPC, it is going to be always, and for all the resources you are going to create, it is very repetitive. It will be the same thing. It will be the resource type, the reference name. So copy the resource type and the reference name, and you will paste it here. So once you paste it, just go in between them, remove the quotes, and add a period. Then come to the end add another period. And remember, it is asking for an attribute from this VPC. What I told you guys is you will find a list of the attribute for your VPC in the documentation. So if I copy that resource type and reference name and I paste it here and I go to that documentation, right? Just click on so you can see here the resource type VPC. So when you create a VPC, there's attributes that comes with it. You'll come to attribute section. So you can see here all the different attributes that exist for that VPC after you create it. So what the Internet Gateway wants is the ID of the VPC. You can see here, it is ID. So that is why we are putting .id here. Whatever that attribute is called in the documentation, that's what you put here, .id. How do I don't know how to remove it, but I'm going to figure out how to remove this auto thing next week. It's kind of annoying. So that is what that attribute is going. That's what this the value of this is. Remember, we are referencing the VPC ID, which is we created the VPC up here. So it will be always, it is always the resource type dot the reference name dot whatever attribute you are trying to reference. So once we add that, the next one is tags. We can just do our tags the same way we did our tags here. So the theme for tagging our resources will be the same way. So here, I'm just going to copy this because sometimes I'm always lazy. I don't like doing all that typing. So I'll copy this and I'll paste it here. Then I'm just going to replace that VPC with IGW because this resource is an internet gateway. So I'll replace it with IGW. That means when we tag it, it will be whatever the value of our environment is, which is dev internet gateway for IGW. The name part for the VPC. The name part for the VPC is so I'm assuming you are referring to the tag. So here it's just like in the management console when you tag a resource, you put a key. So the key is the name. You are pretty much saying for the name of this VPC, the tag that I want to assign is whatever tag you give it here, meaning that when you are looking at it for in the future, when you have a bunch of resources, you can use the tags to filter them. So you can go into your resources later on and say, I want to filter all the tags that has dev VPC name. So you can filter it by the name. So this is something that happens in the management console. So if you tag resources in the management console, you enter name, then you enter the value. So that's what this is saying here. And it's the same thing here. So we've created the internet gateway here. The next resources we are going to create here is the subnets, right? So before we create the subnets, what you guys are seeing here is what is called data source. So I want to introduce that to you guys. So this is called data source. So anytime you see a data here in the beginning, this is a data source. And what this means is that sometimes the resource will already exist. Like sometimes you may have a resource in your management console that is already there, and you want to pull that resource and use it within your Terraform code here. That's when you use data source. So that's one of the ways we'll use data source. We won't use it too much in our project, but there will be some times where there's already resource in your management console that you want to use within your Terraform code, and that's what data source is used for. But here, it is also used the same way. You can see that Terraform gives you the ability to pull the availability zone. So what this means is this data source will get a list of all the availability zones that are in the region you are currently using. Remember, I specify my region here in the variables, and my region is US East 1. So what this data source would do is it would get all the availability zones that are in that region so I can use it. So that's what this means. And here is just the same thing. Anything for every resource type, you give it a reference name. So this is the reference name we've given it. And this is all we need to do. So this means that it will just pull all the, whatever region you are using, it will get a list of all the availability zones that are in that region. So once we get the list of all the availability zones that are in that region, the next resource we are going to create is a subnet. So for resource, this is the resource type to create a subnet. You guys can see here, we are creating one subnet here and one subnet here. You can see that the resource type is exactly the same, but what makes them different is the reference name you give them. So for this resource block, we are creating the first public subnet in the first availability zone. So this reference name, remember, is just any name. You can give it any name you want. And for this second subnet, we are creating public subnet EC2. So the resource type is always the same if for whatever resource you are trying to create, but the reference name is what will make it different if you are creating the same resource multiple times in your code. So for this one, we are going to create a VPC. No, sorry. For this one, we are going to create a subnet. And the first argument here is it is asking for the subnet ID. Exactly what we did up here, the subnet ID. So typically what I always do is if I've already referenced the subnet ID somewhere, I can copy it from here. Then come back here on line 37, not 37, line 26. I'll paste it here. Or you can just reference it again. I'll say since this is the first time you guys are, if this is the first time you are working on Terraform, just reference it again. So copy it here. So that way you get used to it. So copy it here and paste it here. Then remember, you are going to remove the double quotes between them, add a period, then all the way at the end, add another period and type ID, because the value it is expecting is the ID of the VPC. Then the next argument here is the CIDR block, right? Here, we already created a variable for the CIDR block that we called public subnet AZ1 CIDR block. Meaning that for the CIDR block here, remember the CIDR block we were using for our project is let me get that naming convention. Let me just open it. I may have it somewhere here. Just a second. Let me open the naming convention. Remember the naming convention we had, right? Our CIDR blocks that we add for the VPC and the subnet. So for the public subnet AZ1 CIDR block, we use 10.0.0.0.0/24, right? So we can, if you, let's say you hard code it here, you do double quotes and you type 10.0.0.0/24 here, just like that. It is going to work, right? This will work. But for our code, we are trying to make it dynamic where if we want to use this same code for another VPC that has a different CIDR block and subnets that have this different CIDR block, we would have to go and change this. So that's why we don't want to hard code it here. So this is just a preference thing. So instead of hard coding the value, we are just going to use the variable we created for it. So the variable we created for it is this public subnet AZ1 CIDR. We'll copy it. And here we are going to type var. Remember to reference a variable, you type var dot, and you paste the variable name that you are trying to reference. And that is how we reference that variable. Then for the availability zone, remember we got this resource will get a list of the availability zones that are in this region, right? So to get the actual availability zone here. This is how we are going to enter it. Let me drag this here so you guys can see. It is going to be the same concept, the resource type here, and the reference name. But with this one, anytime you are using data source, it is also going to include the data source. So this is the only time you will include the data. If it's the resource type, you don't include the resource type, the way we reference it here. But if it's the data source, you always include the data. So you copy the data, the resource type, the reference name, copy it. Once you copy, we are going to paste it here. Then you are going to remove the quotes between them, add a period between data and AWS availability zone. Then you are going to do the same thing here. Remove the quotes, add a period, right? Then you come all the way to the end. It is going to be dot. And the attribute you want to reference is names. So here you are going to type names. Names like that. And once you type names like that, you are going to enter a bracket. And in that bracket, just like that, you are going to enter 0. So let me explain what this means. The structure is going to be, remember, it is going to be data, resource type, data source, you can call it data, not resource type, but data, data source type, reference name. That's what you have there. And you just put a period at the end. The attribute you will reference is name. And for the names, when you have this bracket and 0 here, this is called indexing. In software engineering, this is called indexing. So an example of this is when we get the data source, right? The data source is going to come like this. So let's say it comes US East 1, 1A, right? Let me just press enter there. It's going to come like this. So it's going to come because US is 1A, US is 1B, US is 1C, US is 1D, and so on, and US is 1F. So whatever availability zone is in your region, that's the amount of availability zone that will show up when we use that data source. So when we call that data source, for example, it will show up like this. So since we have 5 availability zone here, we want to tell it which availability zone we want as our first availability zone. So in software engineering, indexing means that when you get a list of something, because you see this bracket, that's what makes this a list. When you get a list of something, if you enter 0, 0 would select the first item on the list. So 0 is equals the first item. If you enter 1, 1 will be the second item on the list. And if you enter 2, 2 will be the third item on the list. And you guys get the gist. And if you enter 3, 3 will be the fourth item on the list, and so on. So here we are saying that when we get a list of the availability zone and we put 0 here, we are saying once we get that list, whatever the first item is on that list, that's what we want to make our first availability zone. It don't matter what you pick as your first availability zone, you just have to make sure you are consistent. The same way when you were creating your subnets, you have to be consistent. So that is what this 0 means. It's called indexing. So once we enter that, then for map public IP on launch, remember when we change the settings on our subnet that anytime we launch a resource in our public subnet, we want that resource to have an IP address. So that is what this resource type is. That's what this argument means. So here, for the value, we are going to type true. Right. Then for our tags, we'll follow the same way we've been tagging our resource here. So I'm just going to copy this up here and I'm going to paste it here. And I'm just going to modify that name. So it will be the environment. And I'm going to call it -public AZ1. And call it something like that. So it will be whatever our dev public AZ1. You can even type subnet AZ1, whatever you want to call it. Right. So that is what that is. How do I get rid of this? I want to get rid of this.
The autocomplete, right?
Yeah, the autocomplete. Yeah.
So go to
inline suggestion. I think I see it here.
okay.
I'm just going to uncheck it. How do I? Okay. All right. All files. Yeah. Because it's annoying. All right. So that is how we create we've created the subnets that will be the public subnet in the first availability zone, right? So we are pretty much going to do the same thing. So if you've done one subnet, you can use the same concept to create your other subnet. The second subnet we are going to create is the second subnet that will be our public subnet in the second availability zone, right? The argument here is the VPC ID is the same VPC we are going to attach it to. So we can copy this value here for the VPC ID and paste it here. For the CIDR block, remember we created a variable for it. So we are just going to enter var dot, and the variable we created for it is the public subnet EC2 CIDR block. So when you guys are creating your variable, try to make the name of the variable descriptive as what you are trying to create. So that way, when you look at it, it will be easy for you to understand what that variable was originally created for. So I'm going to paste it there, right? And map public IP on launch. Oh no, sorry. The next one is availability zone. Remember, availability zone is the same thing as the data source. So we are going to copy this here and paste it here. But remember, this 0 is the first availability zone. This subnet will be created in the second availability zone. So that means that when we use this data source to get a list of the availability zones, we are going to select the second item on it because we already selected the first item here as our first availability zone. Here, one is going to select the second item, just like I told you guys here, 0. The thing about indexing is it starts as 0. So 0 will be the first item and 1 will be the second item. So that is how we pretty much create subnet in the first availability zone and subnet in the second availability zone. Then map public IP on launch is going to be true. And for the tag, again, we are just saying for the key, it's going to be named, and for the value is whatever we want to call it. So we can call it the same thing as here. You can copy whatever you did for that public subnet EZ1, paste it here. I think I did something wrong, so I'm going to Control Z. We have copied multiple things, so I'm going to copy this and paste it here. Then all I'm going to do is just change this to 2. So it will read dev public EZ2. So this is public EZ1, this is public EZ2. And I'm done with the resource to create the 2 subnets. So far, do you guys have any question? Let me just pause here and take some questions, then we can proceed. Okay, cool. So once we create the subnets, the next thing we are going to do is create our route table. Same thing we did. Remember when we created our subnets? Then we created a route table that is routing traffic to the internet through the internet gateway. Then we attach that route table. We associate that route table with the public subnet, which is what made the subnet public. So you see, when we create the subnet here, we are just creating the subnet, but just because we gave it a name public does not make it public. So how we will make it public is the same thing we did in the management console, which is creating the route table, adding the route to it, then now associating it with a subnet. That is exactly what we are doing here. So here, this resource block will create a route table. So you can see this is the resource type to create a route table, and this is the reference name I gave it. The first argument is the VPC we will create the route table in. We already referenced the VPC here, so you can copy that value from here and paste it here. Then under routes, so this is how you specify the route in Terraform. So it is route, and for that route, it is looking for the CIDR block and the gateway ID. So remember, the CIDR block is going to be anywhere on the internet. So for this one, we can hard code it. We don't have to make it a variable. So we can just type 0.0.0.0/0. Remember, it is 4 zeros/0. So this is this CIDR block for anywhere on the internet. And for the gateway ID, it will be the ID of the internet gateway. Remember, we created the internet gateway here. This is where we created the internet gateway. So here, we are going to copy the resource type and the reference name. So you copy it. Once you copy it, you scroll back down here and paste it here. Once you paste it there, you are going to remove the quotes between them, type a period, come all the way to the end, type another period, and type whatever the attribute it is looking for. For this one, it is looking for the ID. So we are going to type ID here. And that's all you need to do. So if you don't know, if you aren't sure what this is, for example, let's say you saw this gateway ID and you're not sure, just go to the documentation, right? So if you go to the documentation, yeah, for example, you just copy that resource type, paste it in Google. It will take you straight to the documentation. You click here, then you come to the argument section, and here you just look for where it says route. So you can see route here, and for this route here, it is going to give you more information here. So they may have also changed it. So let me see. Let me see, maybe this will. So the reason why this one is not here is that, and I need to find exactly, oh, okay. So it says see example above. So they probably gave you the example above, right? So here. So even though for route, they didn't have this in there, but they are showing you exactly how that route block is. Because you see in that documentation here, it says see example above. So if you look at the example, route, CIDR block, gateway ID. So that is how, so majority, that's what I'm saying, a lot of this thing comes from the documentation. So that's how we got to that. So now the next thing we are going to do is tag this route table. We can do the same thing we've been doing for our tags. We can copy this, paste it here, then remove the name here. So it will be var environment. We can call it RTB for route table. and -public. Public. So this means is the route table. We're tagging a route table, the public route table. So once we've created the route table, so here we created the route table, we add a route to it that is routing traffic to the internet through the internet gateway. Now we are going to associate this route table with the subnet we want to associate it with. This is the resource type to associate a route table with a subnet. The resource type and the reference name I gave it. And it only expects 2 arguments. The ID of the subnet you want to associate and the route table ID you want to associate. So here for the subnet ID, it will be our first subnet, which is this here, the first subnet, right? Public subnet EC1. We'll copy the resource type and reference name, copy it. Then you are going to paste it here. Once you paste it, you remove the quotes. So you can see a lot of these things is repetitive. Then at the end, you add a period to, and the attribute you want to reference is the ID, because it's saying subnet ID there. So that's all we need to do. And for the route table ID, it is this route table we created up here. So we're going to copy the resource type reference name, and we are going to paste it here. Remove the quotes, add a period, and come all the way to the end, add another period and ID. And that is how we reference that. Then we'll do the same thing for associating the route table with the public subnet in the second availability zone. You can see the resource type to associate is the same, but what makes them different is the reference name we give it. So for every resource block you create, they will have their own unique reference name, because that's what you will use to reference them throughout your code. So here we need the subnet ID. So if we scroll up here, this is where we created the subnet in the second availability zone. So copy the resource type and the reference name, and you will paste it here and remove the double quotes, add a period, then come all the way to the end, add another period and type ID. Then once you've done that, we are going to enter the value of the route table we want to associate it with. It is the same route table that we did with the public subnet EC1. So you can just copy the value here from this here and paste it here. And now we've created our subnet, 2 subnets that are going to be our public subnets. We created the route table that is routing traffic to the internet through the internet gateway. And now we associated the route table with the subnets. Exactly the same thing you did when you created it in the management console. So this is why I say it is important to understand how to complete it in the management console first. Then when you do the same thing with Terraform, it makes more sense. All right. So we've done that. The next thing we need to do is create the other subnets. Remember our private subnet, our private app subnet, and our private data subnets. So here, this is the resource type to create a subnet. It is still the same name, subnet, and the reference name is what's different. So the first argument is the VPC ID. So we've referenced our VPC ID. So you can copy it from here. Copy that value and paste it here. Then the next is the CIDR block. We created an environment variable for it here, a variable for it, and that we call private app subnet EC1 CIDR. So we can copy that variable name, and here we are going to type var dot the name of that variable. So you can paste the name of that variable here. Availability zone, remember, it is the data source we are using, so we can copy it from here. Remember, we create this in the first availability zone and we create this in the second availability zone. So for that private app subnet we are trying to create, we will use this because this is the data source to create a subnet in the first availability zone. So we're going to copy that here and paste it here. Then once you paste it, map on IP, map public on IP. Remember, these are going to be private subnets and we don't want them to have IP address. So for this one, we are going to type false. Then for the tag, we can use the same format we are using here. I'm going to copy this. I'm going to copy this here and paste it here. All I'm just going to do is change the name here. And for this, I'll call it private app easy1. So you can type something like this, private app easy1. So it will be dev private app easy1. Then the next thing we are going to do is create the second private app subnet in the second availability zone. So for the value, it will be very close to what we have here. First argument is the VPC ID. So I'll copy the VPC ID here because we are creating it in the same VPC. So paste that there. The CIDR block, remember we created a variable for it here. Private app subnet EC2 CIDR. That's what we call that variable. We'll copy that variable name and var dot, paste that variable name there. Availability zone, remember we will be creating it in the second availability zone. So whatever you've already picked as your first and second availability zone, just be consistent. So since this is our first and this is our second, we'll copy this and paste it here. Map public IP on launch, that's going to be false because it is a private subnet. Then we are going to tag it. So just copy the tag here, paste it here, and immediately just change it. So that way you don't have any error. So we call this private app easy1. We are calling this private app easy2. So we need to create two more subnets. So same concept, we are creating a subnet and we give it a reference name. We call it private data subnet easy1. So this is the first data subnet in the first availability zone. So the argument VPC ID, same thing as this, copy this and paste it here because we are creating it in the same VPC. CIDR block, we created a variable for it. It is the private data subnet easy1 CIDR block. Copy the variable name. Then here, you are going to type var dot and paste the variable name there. Under availability zone, this will go in the first availability zone. So just make sure you reference the right availability zone. This is what we are using for the first availability zone. Copy that and paste it here. Then map public IP on launch. It is a private subnet. We don't want it to have resources we launch in it to have public IP. So we'll call the type false in there. Then for the tag, we can follow the same concept here. Copy the tag name here, paste it here, and just change the value here. So this will be private data easy1. Right. Then we are going to create the last subnet, which is subnet private data easy2. So VPC ID, yeah, copy this value We'll paste it here. Cider block, we created a variable for it. It is the private data subnet EC2 cider. So we copy that. And here, we're going to type var dot the name of that variable. Map public IP, no, availability zone. Remember, our second availability zone is the one with the 1. So copy that and paste it here. And map public IP on launch, that's going to be false. So pretty much everything you are doing with this subnet is repetitive. If you've done one subnet, it's the same concept for all of them. And for the tag name, we can copy this. And paste it here. Then once you are done, let me close this. I don't need this. Once you are done, we just click File and Save All. Or you can save each of your file. So we've saved our file, and that's all we need to do to create the VPC. So now when we run this Terraform code, it is going to create the VPC in our AWS account. And the thing about it is there's one more thing we need to do. For the variables we created for our VPC, we haven't specified the value. So let me show you guys something. I'm just going to move this here, make it 1. And I'm going to open this. If I right click here and I open integrated terminal to run my code, and here I type Terraform, apply, and press enter, you see what it is asking me here? Now it is asking me for the values of my variables because I specified the variables here in this file, but I haven't told Terraform what the value is. So when you create Terraform variables and you don't tell Terraform what the value is, when you are applying the code, Terraform will now ask you for the value. So here it is asking me for my private app subnet is the one. What's the variable? If I enter the value of that variable, then it will just continue going down the list. So this is what will happen when you specify a variable and you don't give it the value. So I'm just going to cancel here. And the way I close that here, we can probably see the state lock take effect, but that we'll address that if it happens. So I'm just going to close the terminal. And remember, for our variables, where we will specify the values for those variables is in the tf-vars file. So under here, any value, let me put this here so you guys can see. Any variable you have to list them here and enter equals to what the actual value is. So in our reference file, there is a tf-vars file, it's the one with the Terraform. So if you double click on that to open it, you'll see it here. And you just want to copy just everything under the VPC. So copy that. And we are just going to use it here. And just to show you, you can see this VPC cider is the same as this. This is the same as this. And this is the same as that. So pretty much whatever variable name we have here, that is what I have listed here in this format. And I list them equals to what the value would be, right? So if we are following our naming convention, our VPC will be 10.0.0.0/16. So that's what we'll enter here. In double quotes, it will be 10.0.0.0/16. Then for our subnets, we are using 24. 10.0, the first one starts with 10.0/24. So here, public subnet is the one-sider is 10.0.0.0/24. 1.0/24. Public subnet EC2. I'm just going to copy this. EC2. Paste that there, but it will be 10.0.1. So I'm going to change that to the 10.0.1.0/24. And I'll do the same thing throughout. I'll paste it here. So that is 1 here, it will be 2, because that's in like the sequence we had it. And here, this will be 3. And for my data, EC1, that will be 4. And data EC2, that will be 5. So it's just like once you start writing your code, you'll find shortcuts to just be more efficient, right? So basically, all I did here is enter the values we specify for our CIDR block, right? And that is from when we did it in the management console. So this same CIDR block we have here, that is what I've entered here. So once you've done that, I'm going to save that TFVAS file. That's going to save all. And I can move it here. Then I'm going to open the integrated terminal again. And here, I'm going to run Terraform apply again. Once you run Terraform apply, press enter. So this is exactly, I'm glad this happened, right? This is what I was saying when I changed the, when I applied Terraform, and it was asking me for the value of my variable, and I didn't want to enter it, and I just closed the terminal. So this is exactly how the state log works, right? So when we run Terraform initially, and it was asking me to put the value of my variables, and I say, okay, I just abruptly closed the terminal. But when I type that Terraform apply, Terraform has already locked the state to start preparing to apply the resources in my AWS account. So when you are applying Terraform and you abruptly kill Terraform, now Terraform is still waiting for you to apply stuff and it's still keeping the state lock. So that's what you guys are saying here. So this is how that state lock works. Because I already ran that Terraform apply, it has locked the state, nobody else can apply. So now that I'm trying to apply Terraform again, it is saying that the state is already locked. There's another apply that's going on somewhere. Wait for that one, or if I want to force the state lock, I can do that here. So anytime you guys abruptly kill your terminal and Terraform state is locked like this, since we are using DynamoDB, I'm glad this happened so that way I can show you guys how to unlock it. There's like a command you can run to unlock it, but the surest way to unlock it is we are going to go into our AWS account. We are going to go into the AWS account that we created our DynamoDB. So you'll go to DynamoDB and select DynamoDB under services. So once you select DynamoDB, in DynamoDB, here you select tables and you see your Terraform state log. Yeah, select it. Then once you select it, you will see explore items here. Click that. And in this table, when you are exploring the table items, right? Whatever you see that has information, that is currently what is locking your state. So in this table, anytime you run Terraform apply, it will create an item in the table that is locking the state, right? Once it is done, the information will be, you won't see it, like this is the past state log when I apply Terraform, right? And now it has unlocked it, that's why you don't see anything here. So basically, when you come into your table and you explore the table items, whatever is locking your state would have information under the info. So once you see that information there under this info, just delete this one. So you can select this item, select action, and select delete item. Click delete. So that's going to delete that item that is locking your state. So now, once that will unlock it, then you can come back to your Terraform code here. And here, I'm going to type Terraform apply again. So Terraform. This something is in the way I can't see. Just a second, let me move this up. I'm going to type Terraform. Terraform apply. So when you type Terraform apply, press enter. And you can see it is working now. Right. So here, when you type Terraform apply and press enter, it is going to first show you the plan. Right. So based on whatever I wrote in my code, that's what you are seeing the plan here. It's telling you I'm going to create route table. I'm going to associate it, pretty much all the things you see here. So if you see a plus, that means it is adding it. If you see a yellow, it means it is modifying something that exists. And if you see a red, it means it is removing something. And at the bottom of your plan, here it is saying it is adding 9 resources. It is going to change 1. But this is because I created, remember last week when I was showing you guys the example, I already created the VPC, right? So it is just modifying that VPC because now I've changed things in the VPC, right? So that's what that is. But if you guys are applying for the first time, you should see 10, creating 10, change 0, destroy 0. So once you review the plan, it is asking, do you want me to apply it? We are going to type yes and press enter. And now it would create the VPC. So it is creating the VPC, the subnets, the route table, and everything. So we just give it time to create it. It shouldn't take that long, and it will be done. And here you can see the summary. You can see it is creating private data subnet, creating private app subnet. So pretty much all the stuff it is creating, and it is done. Now, if I go into my management console and I type VPC here and select VPC, and here you can see if I filter, I already have the VPC there. It's the dev VPC. And I go in your VPC, you can see my VPC there. If I click subnets, you can see all my subnets. These are the tag name that I gave it. These are the tag name, right? If I scroll here, you can see the CIDR blocks. If I scroll here, you can see the AZ, the availability zone. And that's pretty much, if we go on the route table, you can see we have one route table that we call public. If we select it, routes, you can see it's routing traffic to the internet through the internet gateway. Subnet association, it is associated with these subnets. You guys give me just a second. I'll be right back. Okay, so that is pretty much it. What else? And we already saw the internet gateway. If we click here, you can see the internet gateway. So with that, we are pretty much done with creating the VPC. Good thing about Terraform is the apply we did created the VPC. Now we can go and create the next file for the NAT gateway. The next resource we'll create is the NAT gateway and continue creating our resource. Terraform is able to keep track of all this. So we don't have to delete the VPC. We can create our NAT gateway resource. And when we create our NAT gateway resource and we run apply, Terraform knows that it is only going to apply the NAT gateway because it will look at the state file and say, okay, the VPC is there. The only thing that has changed is this new resource, and it will only add the resource you add. So that is it for the VPC. Does anyone have any question?
Yes, I do have
Okay,
a question.
go ahead. What's your
So,
question?
so this current method we are using is assuming that we are going to be putting everything as a single file in
Yes.
the blocks. So this is not the modular part, right?
No, this is not
Okay.
Terraform module. So this is
Okay.
um putting when you have all your resources, all your files in the same directory. Your Terraform configuration is running all the files from the same directory. Yes, this is not module. This is just regular Terraform.
Okay. So my second question is going to be on not including NAT gateway in the VPC module.
Yeah.
So is there any reason why you did not include it, that you want to make it a separate file? Because from what what I know, you said anything that has to do with a particular platform like NAT gateway being part of VPC should be included. Is there a way why you are not including it there, that you want to make it a separate file?
I mean, it's a preference thing. You can include it and you can remove it, right? The reason why I separated it is because let's say you are creating other resources. If I include the NAT gateway in this VPC, so once you apply this VPC, the NAT gateway will be created too and everything, right? But if you select, honestly, it's just a preference. It's just a preference thing, right? Um, you can also have separate file for the NAT gateway. And the reason why I'm even doing separate file for the NAT gateway is like, this is going to also gear into the module. So once we are done with this, it is going to relate, everything is going to transfer to the module. So I've always kept my NAT gateway separate. So that way, if I'm writing all my resources and I don't want to apply the NAT gateway, I won't apply it. But if I put it in this VPC file, when I apply this VPC, I'll be applying the NAT gateway too. Really, there's no right or wrong way. It is a preference thing. So the VPC, there's also other resources that are there, right, that you can include. But for me, I just like separating the NAT gateway from the VPC. So that's why I did it this way. But there is no right or wrong way for doing it. If you want to include your NAT gateway in your VPC, you can do that.
Okay.
All right. Do you guys have any other question? Okay, cool. On YouTube, you guys are good. You guys following so far?
Sorry, this.
Yeah, sure. Go ahead.
Yeah. So if we want to include that gateway to the VPC right now, we can do that instead of creating a different file for that. Is that possible?
Yes. So once I start the NAT gateway, if you guys want to include the NAT gateway, just come to the bottom of the VPC here and just whatever resource I
Okay.
have for the NAT gateway, just add it there.
All right. Thank you.
Okay, good. Thanks, Chaga. All right, cool. All right, so we are done with this. I'm going to close the terminal, and next we are going to create the NAT gateway. So in the reference file, I have a NAT gateway file there. So the NAT gateway file, where is it at? Right here. So you can either create a new file here. So I want you guys to get used to the same thing. Like either get used to creating your file here from this app, your project directory. So you can say new file here and you call it natgateway.tf, or you can also take this NAT gateway reference file that I gave you, which is what I'm going to do. And I'm going to drag it in this Nest app. So you see where my mouse is, I'm touching that Nest app. So that is how it is going to put it in the same directory. So that is the NAT gateway. This is the resource type we use to create the NAT gateway. And I'm going to the reference file is part of the project information. Hold on. Let me get it for you. So that should be in your email. I sent you guys an email on that from last week. So I'm not sure if I have your email, but yeah. So in that document, that's how you download the reference files. Okay. So for our NAT gateway, we're just going to go straight into creating it because I don't think we have any variables for this one. So for those of you that prefer to create your NAT gateway in your VPC, so here you can see I have my VPC, here I have my NAT gateway. You can copy everything here and just paste it under your VPC. It's the same thing. Okay. So the reason why I have the two of them, so on the left side here, this is my VPC resource that we create. And on the right side, this is my NAT gateway. I only have both of them here because if we are referencing something, I want you guys to see how you can go back and forth to reference things. So that's why. You're welcome. You're welcome, John. So to create our NAT gateway, remember our NAT gateway, first we have to allocate an elastic IP address, right? That is what this resource is doing. This resource would allocate an elastic IP address. And once it allocates the elastic IP address, that is what we will use for the NAT gateway. So here, this is the resource type to allocate an elastic IP address. And this is the reference name that I gave it. Under this argument, it says domain, and what the value it expects there is VPC. So here, just type VPC. That is always going to be in lowercase, type VPC. Then for tags, we are going to just follow the same naming convention here. So I can copy it from anywhere in the VPC and paste it here. Then I'm just going to modify the name. So here I'll call it EIP. EIP 1. So just call it dev EIP 1. So once we allocate the elastic IP, we are going to create the NAT gateway. Remember, to create the NAT gateway, this is the resource type to create a NAT gateway, and this is the reference name I made for it. Under allocation ID, right, this is the elastic IP that we are going to allocate to this NAT gateway. Remember, we created the elastic IP up here. So remember to reference it. It will be the resource type and the reference name. Copy and paste it here. Then you remove the quotes, add a period. The attribute it is asking for is the ID. Majority of the argument will tell you exactly what it wants. If it's the ARN, it will say ARN. If it's ID, it will say ID. So whatever it says here, just 9 out of 10 times, that's what you will enter there. So since it is asking for ID, we'll put ID there. Then remember, we have to create our NAT gateway in a public subnet. NAT gateway goes in a public subnet. So here it is asking for the ID of the subnet we want to create a NAT gateway in. Remember, in our VPC file, we created our public subnet AZ1 here and public subnet AZ2 here. So you can create your NAT gateway in any of those subnets. So if you want to create your NAT gateway in the public subnet AZ1, you are going to copy this. Once you copy it, you are going to paste it here. Then you are going to remove the quotes, add a period. At the end, add another period and enter the attribute you are referencing, which is the subnet ID. So here I choose to create it in the public subnet AZ1. But if you want to create it in public subnet AZ2, you can do that as well. Then for the tags, we can follow the same thing here. So copy this, paste it here, and we are going to add the name. So it's going to be NAT gateway. And we'll call it NAT gateway AZ1. So that's the tag name. And here, this is another thing I want to introduce to you guys. In Terraform, you can have these things. They are always optional. For the most part, Terraform understands how to. So if I put resources, NAT gateway, VPC, Terraform, 99% of the time, Terraform understands how to create those resources in the order they need to be created. Because first, we can create our NAT gateway before creating our VPC. We need to create the VPC first. So Terraform understands all that stuff. But for some resources, you need to add a depend on. So that with that depend on, you are adding an extra instruction for Terraform to say that Terraform, I need you to create this resource before you run this resource. So for the depend on we are using here, we are going to say it is depending on the internet gateway. So to do that here, we are going to add a bracket, and you can, in that bracket, remember I told you guys, anytime you have a bracket here, this means it is a list, meaning that you can put multiple things in there. But we're only going to put one thing. This NAT gateway is going to depend on the internet gateway. The internet gateway resource is here. So we are going to copy the resource type and the reference name, copy it, and we will paste it in here. So once we paste it, the same thing, we are going to remove the quotes, add a period. But when you are using the depend on, you are not going to add any attribute because there's no attribute in this we are trying to reference. We are saying that this resource as a whole, create this resource first before you create this NAT gateway. So that's what this depend on does. So when you add this, Terraform will make sure it creates this internet gateway before the NAT gateway. And the reason why we have it there is because sometimes when you are modifying it, it can run into issues where it is trying to either delete one before the other, but when you force it to create it in this order, it would first always handle the internet gateway before it starts creating the NAT gateway. So that's what it depend on does. So this is how we create the NAT gateway. Then remember, once we create the NAT gateway, we are going to create a route table. The same way we created a route table here. It's the same thing, right? So the route table is resource type, reference name that I gave it. So this is the route table that will route traffic to the internet through the NAT gateway. So for the VPC ID, it is the same VPC ID we've been using. So we can copy this and paste it here. For the route table, for the route, similar to what we did here, right? CIDR block, right? You know, the route table for that's routing traffic to the internet through the NAT gateway kind of works similar as the public route table. The only difference is one is routing traffic through the internet gateway. The other one is routing traffic through the NAT gateway. So here, the CIDR block is going to be anywhere on the internet, which is that one. So we'll copy and paste it here. And here is asking for the NAT gateway ID. We created the NAT gateway up here. So copy the resource type and the reference name, copy it and paste it here. Then you remove the quotes, add a period. At the end, add another period and type ID, because the attribute it is looking for is the internet gateway ID. So we're going to enter the tag next. You can just copy this, paste it here, and modify this to say, oh, I could have copied it from the route table here. So it will be RTB private. Let me look that. I think I have a typo. So it'll be RTB private. So that's how we create the route table. And you guys can see the difference between this route table and that route table. They are pretty much identical. The only thing is like the reference name, we gave the resource, and whatever they are routing traffic through. One is routing traffic through the internet gateway, the other one is the NAT gateway. The same way with same thing we did in the management console. So the next thing we are going to create now that we've created the route table and add the route, we are going to associate it with our private subnet. So here we will associate the same route table with private app subnet EZ1, private data subnet EZ1, private app subnet EZ2, private data subnet EZ2. So the same example of how you associate here is the same concept applies here. So once you have the resource type and the reference name, first you are going to select the subnet ID. The subnet, the ID of the subnet we want to associate here is the private app subnet EZ1. So in your VPC, look for your private app subnet EZ1, right? Private app subnet EZ1. This is the subnet. So you will copy the resource type and the reference name, and you will paste it here. Remove the quotes, add a period, then here, add another period and type ID. Then the route table we want to associate it with is the route table we just created here. So we are going to copy the resource type and the reference name. And we would paste it here. And it would here, add a period and type ID. So I have another quote here. So make sure anywhere you have the quote, make sure you remove it. And in Terraform, you will see the color code. As long as you are using that Terraform extension that I showed you guys last week, everything, the color code will match each other, what they are supposed to. Strings will always be in this color unless you change it. Anything that's like referencing the resource type will be in this color. So that is how we associate our private app subnet EZ1 to the route table we just created there. We'll do the same thing for the private app subnet EZ2. So this one is not private app subnet EZ2. So please pay attention to what I have there. I could have just done private app subnet EZ1, private app subnet EZ2, private data subnet EZ1, private data subnet EZ2, but I think I have it mix and match, which could be confusing. So you can reorder them if you want, or you can leave it like this. So this is asking for the private data subnet EZ1. I think when I was doing it, I was trying to do all the EZ1 and all the EZ2. So here it is asking for the private data subnet EZ1, which is this one here. So I'll copy the resource type and the reference name and paste it here. Then I'm going to remove the quotes, add a period, and I'm going to here add another period and type ID because that's the attribute we need. For the route table ID, it's the same route table. So copy this route table ID here and paste it here. So we've done private app subnet EZ1, private data subnet EZ2, EZ1. Here, we are going to associate the private app subnet EZ2 with the route table. So here, we are going to copy the resource type and the reference name for that subnet for private app subnet EZ2. Copy it and paste it here. Then remove the quotes, add a period. At the end, add another period and type ID. Then for the route table ID, it is the same route table. So just copy the value from here and paste it here. And we are done with that. The last one is the private data subnet EZ2. So if we scroll down here, private data subnet EZ2. So copy the resource type and the reference name, paste it here. Remove the quotes, add a period. To the end, add another period, type ID. And for the route table, is the same route table. So copy whatever you entered there and paste it here. And that is pretty much it. We'll save our file. And we are done with the NAT gateway and the route table. So I can just move this here. And to apply it, we would open the File Explorer here, right-click on any of your Terraform file, click Open in Integrated Terminal. That will make sure that Terraform opens into the directory because you need to be in the same directory as your file to run your Terraform code. So once we're in that directory, we're going to type Terraform, apply, and press enter. So it is showing us the plan here. Anytime you type Terraform apply, it is going to show you the plan. So you can review the plan. Anything in green is what it is adding. And at the bottom, you can see here, the plan is to add 7, change 0, remove 0. So once you are happy with the plan, here, you are going to type yes and press enter. And now it will create the NAT gateway with the route table, with the subnet associations, elastic IP, everything. And that's what it is creating based on what is in my NAT gateway. So you guys can see that Terraform is very smart where it is able to keep track of the resources it has already created and is able to keep track of the resources it has already created and add the new resource. So we'll just wait for it to create the NAT gateway. And some of these things you can actually see. So let's say we go into the management console now, right? And we select NAT gateway. You can see that a NAT gateway is being created. The state is pending. Usually once Terraform creates it and it can tell that everything has created, the state has changed, then Terraform would tell you that I've created all the resource. So you can see it here. If I go and check the route tables, you can see it hasn't created the route table yet because it's probably still creating the NAT gateway. So it knows how to create these resources in the order they need to be created. So once the NAT gateway state change, it is probably going to go ahead and create the route table. So pretty much whatever you are seeing here in the output, you can go in the management console and check it. So we'll give it some time, and in that time, does anyone have any question? Gideon, yes, I still have the domain name. I mean, did you send me an email recent? Send me another one now. Not now, but like recent, because I think you sent me one before I registered it. But yeah.
Question.
Yes, sir. Go ahead.
Aziz, please. Terraform state file. You said it can be stored in the S3 bucket.
Mm-hmm.
Is it possible to store it in the Git?
And like GitHub repository.
Yeah.
I don't, maybe, but I don't know. I don't think so. It could be, but I don't know. Right. So it's just wait, how
Because since Terraform is cut across various infrastructure, why restricting it only to S3? I believe other cloud services have their own way of storing it. Like Azure probably will have their own storage. Why Google will have their own storage. So I'm just thinking that is it possible? Maybe I will try to experiment it anyway. Maybe we can store it in the GitHub and see how maybe it will work.
I think I have to look in Terraform documentation to see what different storage you can store it. but you need to pick a storage. So I think the difference would be GitHub is a repository, it is not a storage, right? So where we are storing it is a storage, not a repository. So I think that's probably one of the ways, one place where you are going to run into an issue.
Okay.
And two is just what I've seen is whatever cloud platform you are trying to store your, whatever cloud platform you are trying to deploy to, is best to just put your storage there, because then since I'm already connected to my AWS account, it is easier to authenticate and put everything there. If I have GitHub now, then I have to set up like a GitHub. I'm not sure if that will work. I don't want to say, I honestly, I don't know. I've never thought about it to use GitHub. So someone said, yes, we can't store state files in GitHub.
We can't.
We can't, because it says it violates GitHub policy.
Okay.
So yeah. So with a lot of these things, right? Simple is always better. That is true. Go. Thank you so much, Shab. Thank you. So with the thing about GitHub is with Shuba just mentioned, right? With the state file contains a bunch of, if we go and download a state file now from our state file bucket, right? It contains any secrets we have in our Terraform that we are building and all that stuff, it is all in that state file. So, and you guys know, according to GitHub policy, like you can't put anything secrets in your GitHub repository. So that kind of like violates the policy there. So it's just not meant for it. And it's like where you need to be storing it is in any storage. So if you are using Azure, you'll be storing it in Azure Vault, Azure storage. If you are using Google, whatever storage is in Google, that's where you'll be storing it. So you need to like just pick like a storage. And I think everyone picks a central storage based on where they are trying to deploy to. So yeah, and even if GitHub was allowed, it would be overkill. So when you guys are doing stuff, is as long as it works and you implement security and everything, it's always good to pick the most efficient and easiest way, so that not only when you write the code, if other engineers comes into your company, they can easily pick up your Terraform code and understand what's going on. Yes. So Shuba said, Terraform state file contains secrets in plain text, such as database password, API token, and SSH keys that we can store in GitHub. So yes, I agree. So that's a very valid point. Thank you, Shuba.
Okay.
So yeah.
Thanks, man. Another question. The DynamoDB, if I can still remember vividly that we store some secret in it, right?
No, we didn't store secret in DynamoDB. We are only using it for state lock. We are using it to lock our state file. So the job of the DynamoDB is when we are applying Terraform, it prevents any other person to apply Terraform at the same time.
DynamoDB. I think we created a table where we store the secret password.
Secrets manager, that's secrets manager.
Okay. All right.
Yeah.
Thanks.
No problem. All right. So if I go into the management console now, I'm going to select NAT gateway here. You can see my NAT gateway. I'm going to select route tables here. I'm going to refresh here. You can see the route table I just created. 4 subnets are associated with it. If you go into it, click on routes, you can see it is routing traffic through the NAT gateway. If you click on subnet associations, it is associated with the private app and private data subnets. And also, if I click on Elastic IP here, you can see the Elastic IP we allocated. And the tags that I was giving it, remember I was giving it environment, hyphen, whatever the resources, that's why you're seeing here. Since my environment is dev, you can see here it's called it dev EIP1. So we are pretty much done with the NAT gateway. Does anyone have any question? All right. So the next resource we are going to create is the security groups.
Sorry, Azeez.
Go ahead.
Sorry to cut you there. Please, is it always possible, or is it always the case that you have to build it a bit by bit, or can you just do all and just run it at once?
I mean, it's up to you if you want to build all your code at once or if you want to build it bit by bit, but it's always good to build it piece by piece because you can easily troubleshoot any issues you have along the way. If you write all your
Okay.
Terraform code and because there's no way you will write a code all the way through that you are not going to have typos here, resource mismatch here and there. But I would say build it one resource at a time. So that way, if you build your VPC and you run into any error while you are applying, you know you only have to troubleshoot that. But if you write all your code and you now have issues with like different sections where something is not matching here, it'll just create more chaos to troubleshoot later on. So it's better to just build it piece by piece, I'll say.
Okay. All right.
For
Thanks.
troubleshooting purpose, yeah. All right, cool. So the next resource we are going to create is the security groups. So you can right click here, create a new file for the security groups, or you can come to that reference file and the security groups file is here. Just drag it and drop it on the Nest app. So just make sure wherever you placed it, it is lining up with all your other Terraform configuration file. And this is the security groups we are going to create. Remember, for that dynamic project, we created a security group for the EC2 instance connect endpoint, the application load balancer, the EC2 servers, the data migration server, and the RDS database. So the same thing we did in that project is what we are doing here. So let's, what will I need to reference here? Maybe VPC. So I can put this here. I'm going to close some of these other, I don't need the variables for now. So let me do it like this. So my VPC is here. Honestly, to be honest, we don't even need it because we only just need that ID. So we can just work with this like this. So the first security group, you can see we are creating 5 security groups. The resource type for all of them is security group. The only thing that's different is the reference name we gave it. So the first security group we are going to create is we'll create the security group for the EC2 instance connect endpoint. So for the name of the security group, we can just give it pretty much a name that we want, right? So for the name, we will follow the same type of naming convention we've been doing. So let me just select any of this, and I'm going to copy anywhere where I had that tag. So then I'm going to close that. And for the name, you can paste it here. And let's do this. So it will be this bracket, and I'm going to remove that. So we can call it this $, the environment, hyphen, $, here, it will be var project. No, so let me just get the real name so you guys don't get confused, right? So here, I'm going to go to variables, put that here, right? Remember, we have a variable name, project name, so we can copy that variable name and paste it here. So it'll be var project name, then we can now do another hyphen. And we can say EICE-SG. So this is the name we'll give it. So I'm introducing now, including our project name. So the reason why I didn't do this with the VPC is because you can have one VPC and you can create multiple applications in your VPC, right? So that's why I didn't make the VPC name tagging name specific to a project. So now that we are getting into not that it matters, but I'm just showing you how you can keep a single name for your VPC and for your other resource, how you can still introduce something like this. So this is going to target dev, the name of our project, Nest, AIC security group. So when you are looking at the security group, you know it's for the Nest project. So once we have the name, the description is pretty much what it's creating. So it is going to create an outbound SSH to the VPC side, right? And the VPC ID is the ID of the VPC we want to create the security group in. So you can click any of your file where you have your VPC ID. So the VPC ID is referenced here. So I'm going to copy it and I'm going to paste it here. Then for the egress, right, from port, that is going to be 22. Remember, for your SSH, the EIC is what we use to, EC2 instance connect endpoint is what we use to SSH into our EC2 instance. And remember when we created a security group for it, we only open port 22 on the outbound. So that's what we are seeing here. From port is going to be 22. To port is also going to be 22. The protocol is going to be TCP. So in quote, TCP. And the CIDR block is going to be the CIDR block for our VPC. So here, this is important. You have to have the bracket because if you see CIDR blocks here with an S, it means it's expecting a list. So here, it's only one we are going to put there, but that the list just means you can put more than one. But for this case, we're only going to put one. So it's CIDR block for our VPC, which is var dot. Remember, we created it as a variable. Yeah. So we created it as a variable VPC CIDR. So it'll be var dot whatever the VPC CIDR is. So we'll copy this and paste it there. And for the name, for the tag name, we can just use the same name we use up here. So copy this and paste it here. And that's it. And one thing I want you guys to pay attention to is, and I'll explain it here. When we create the security group and we have yeah, so dynamic block. Yeah, I didn't want to introduce dynamic blocks in this lecture since a lot of people are probably just starting for the first time. I didn't want to confuse them too much. So I just wanted to keep it basic to just how to create a security group. Then maybe in a future course, I can show you guys how to kind of create a dynamic block with your security groups. Yeah. So this one thing I want you guys to pay attention to is here. You guys know on the EIC security group, we only open the outbound, right? So now, and when you are anything that is outbound in your Terraform code will be egress. So you see how you see egress here? That means it is outbound. So now when we are creating the next security group where we actually have an inbound, you can see that it says ingress. So that's one thing I want to point out. Anytime you see ingress, that is for your inbound rule. And if you see egress, that is for your outbound rule. So the next security group we will create is for the application load balancer. Remember, for the application load balancer, we had to open port 80, port 443, and port 22. No, just port 80 and port 443 for internet traffic that is coming from HTTP and HTTPS. So in here, the first argument is the name. We can just copy the same style here. Copy this, paste it here. And we'll just modify it here. So we can call this ALB-SG. So once we give it the name, we have the description here. We want to open HTTP and HTTPS from the internet. VPC ID is the same VPC. So you can copy your VPC ID from here and paste it here. Once we add that, then we'll do our first ingress. Remember our first ingress, HTTP is on port 80. So the front port is going to be 80. The to port is going to be 80. The protocol is going to be TCP, in quotes, TCP. And the CIDR block, right? The CIDR block is going to be where we are allowing the traffic from, right? So remember, we're allowing traffic from anywhere on the internet. And remember that CIDR block is going to be 0.0.0.0/0. I hope I have, 40/0. So that's all we need to do here for the inbound rule. For the second inbound rule for the HTTPS, it's pretty much the same concept. HTTPS is 443. So here we have 443. 2 port, 443. Protocol, TCP. CIDR blocks, pretty much the same thing as here, anywhere on the internet. So copy this and paste it here. Then for the egress, right, is the outbound. Remember that is always like all traffic. So how you do all traffic in Terraform, and this you can see it in the Terraform documentation for security groups, is front port is 0, 2 port will be 0, protocol will be -1, that is the all traffic -1, and CIDR block will also be anywhere on the internet. So you can copy this and paste it there. Then for the tag name, just use whatever name you used up here. Copy this and paste it here. As my Zoom thing is in the way, so I'm just going to Control V, paste it there. And there you go. We have created the security group for the, yes, I believe -1 is the all traffic protocol. And once I apply it, I will verify, but I think that's the all traffic protocol, but we'll see what it is. So the from is 2. So you see how this is TCP here, but the protocol is TCP here, and this one is -1, but I'll check. Don't hold me to it, but once I apply it, I'll verify for you guys. Yeah, it could be all traffic, but I think it's all traffic if I'm not mistaken. So we've created the security groups here, right, for the ALB, and it's the same concept for the other ones, right? The next security group we'll create is for the EC2. Remember on the EC2, we opened port 80, port 443, and port 22. For the port 80 and port 443, we are only going to allow that traffic if it is coming from the ALB, right? So it's the same concept we are going to follow here. So first, for the name, we can follow the same concept here, copy this, and we will paste it here. And for the ALB, for the name, we'll just call it environment, and we can call it WebSG. So here, WebSG. The description is HTTP and HTTPS from ALB, SSH from the EC2 instance connect endpoint. So first, we need the VPC ID we want to create it in. So we can copy it from here. And paste it here. Then for the ingress, this is where we are allowing port 22 from the EC2 instance connect endpoint. So here we are going to enter from the front port is going to be 22. To port is going to be 22. Protocol is going to be TCP. And the security groups, we are going to allow it. Remember, is the EC2 instance connect endpoint security group. So here you copy the resource type and the reference name of that EC2 instance connect endpoint security group. Then here, remember, it is expecting a list. So you have to have a bracket and paste it in there. Then you are going to remove the quotes here, enter a period, remove the quotes at the end, enter a period and type ID. And that is how we open this port, but we limit it to the security group that we created previously. So for the ingress, for the HTTP is the same thing. From port is going to be 80. To port is going to be 80. Protocol is going to be TCP. And security groups ID, remember, it is the security group we created up here. We are limiting it to the load balancer security group. So copy this here. And here, we're going to add a bracket, then paste it in there. Then remove the quotes, add a period, and here, period ID. And that's it, right? So that's it for the HTTP. Now we want to do the same thing for the HTTPS. Remember, HTTPS is 443. To port will be 443. Protocol is going to be TCP. TCP and security group is the same as this, so you can just copy this one and paste it here. For the egress, it will be the same thing as what we did here. So 0, 0, -1, anywhere on the internet. So I'll just copy this here. So here it will be 0, 2 ports, 0, -1, and paste this here. I don't know why this something is always in the way. Paste this here. Then for the tags, we are going to just use the same name and paste it here. And that is it for that one. So moving on, the next security group we are going to create is for the data migrate EC2 instance, right? So because in this project, we will use Terraform to do the full deployment. Terraform is going to migrate our data into RDS with Flyway. It is going to do everything. So there's not going to be anything we'll have to do manually. So this is the security group we will attach to that EC2 instance that will migrate our data, right? So here we want to first give it a name. So giving it a tag name, we can use the same naming convention we've been using, that, but at the end, we can just call it data migrate server. So we'll call it DMS SG. And we need to create it in a VPC, right? We can copy the VPC ID from up here. So copy the VPC ID. And paste it here. Under the ingress, right, it is allowing SSH from the EIC, right? So from the front port, we are going to allow front port is going to be 22. To port is going to be 22. Protocol is going to be TCP. And security group, remember, it is the EIC security group, because this is the security group we are creating for the data server, right? So we can copy it from up here, or you know what, let's do it this way, because we reference it in this here, where we are limiting it to the EIC security group here. So we can copy it from here. Or if you want to do it, it's the same thing as copying the resource type here and reference name. It's the same thing. So copy from here and paste it here. Then for the egress, it will be 0, because it needs to be all traffic 0, -1. And the CIDR block is going to be anywhere on the internet, same as this. Copy this and paste it here. And for the name, you can copy the name that you created up here. Oh no, I didn't mean to call it. Copy the name and paste it down here. And the last security group we are going to create is the security group for the RDS. So first we'll give it a name. And here we can remove that at the end. And let's call it DBSG. So we need to add the ID of the VPC we want to create it in. We can copy it here and paste it here. You guys see a lot of stuff with Terraform is just referencing and copy pasting. Ingress rule, right? Remember, we are going to open, this port is going to be for the servers, right? So here, MySQL is the engine we are using. So the front port is going to be 3306, because that is the port for MySQL 3306. And the to port is also 3306. The protocol is going to be TCP. And the security group we want to limit it to is the app server security group. Remember, this ingress will allow traffic on 3306 only if it is coming from the app server. So we have to go to where we created the app server, which it is right here. So we'll copy the resource type and the reference name. Once we copy it in quotes, in the bracket, we'll paste it here and remove the quotes, add a period, come to the end, add another period and type ID. And it's pretty much the same thing we are doing for the ingress here, but this would be limited to the migration server security group. So here we are going to type 3306 again, because the database is going to allow traffic from 3306 only if it is coming from the data migration server. So here, to port is 3306. Protocol is TCP. Make sure you have double quotes, TCP. And the security group ID, remember, traffic will be coming on 3306, and we're only going to allow it if it is coming from our data migration server. And this is the security group we are using for that data migration server. So we'll copy the security group. And here we'll add our bracket, paste it in there, remove the quote, period, at the end, period ID. Then for the egress, it's the same thing. This is your outbound rule. It's 0, 0, -1. And CIDR block will be anywhere on the internet. So I'll just copy it from up here and paste it here. And for the name, you can copy the name here, the tag name, and paste it here. And that's it. We are pretty much done with all the security groups. So there's pretty much all this, whatever we add here is the same security groups we created in the management console. So we have 5 security groups. All you have to just study is for our EIC, when you created in the management console, what did you create? And you only open port 22 on the outbound. This is how you do that here. For the load balancer, you open port 80 and port 443. This is how you did it. So once you find the structure, you just place in the port number and this port number and the protocol and the CIDR blocks there. That's all you're doing. And it's pretty much repetitive after that.
Azeez,
Yes.
I noticed in the management console, we don't use egress and ingress. So why is it different in this one?
Yes, we do. We have ingress and we have ingress and egress, but in the management console, it's called inbound and outbound.
Okay. Okay.
Yeah. So that's what I was saying earlier. Whatever is under ingress is inbound, and whatever is on egress is outbound. You are confused with the ingress and egress. Okay. So,
Thanks.
so you have a security group, right? In the management console. Let me just show you guys. The management console, you come here to security group, you create a security group, you give it a name, right? And call it test. So I can even put this side by side so you guys can see. Just let me see if this will work. Right. So in the management console, when you are creating a security group, let's pick the one that has the ALB one, right? So you give it a name, right? That's what you're seeing here. Then a description, that's what you're seeing here. Name, name, description, description. VPC, VPC. Inbound, inbound, ingress. So under this inbound, let me change this. Under this inbound, I can now click add rule, right? And here I'm going to select HTTP. HTTP is port 80, right? It's just because you can, because the way I have this thing, let me see if I can drag it a little bit more. Oh, okay, showing down here, never mind. HTTP is port 80, right? And the source is anywhere on the internet. So that's what you guys are saying. HTTP, port 80, port range, port 80, protocol, TCP, and source, anywhere on the internet. That's that, right? Then if we add another rule, let me just clear this drawing since I'm scrolling now. So if we add another rule, HTTPS 443, HTTPS 443, protocol, TCP, CIDR block, source, anywhere on the internet. Same exact thing you did in the management console, right? So inbound rule, you can see here, inbound rule counts as ingress. Then once you add all your inbound rule, you add outbound rules. Outbound rule is egress. So what I'm saying is from port, right? You can see here it is all traffic. So how you specify, so Shuba, show you, thank you for that. So you can see here from port is all traffic. So how you specify all traffic in Terraform is 0. Then protocol is also all, right? How you specify all is -1. and the destination is anywhere on the internet. That's why you have 0 there. So that's the inbound and outbound. So in Terraform, it is called ingress and egress. Do you understand now, John?
Yes, thank you.
Yeah. Okay, cool. So yeah, it's pretty much the same thing, you guys. So that's why I'm saying anytime you're working with your Terraform, if you get confused, just pretend as if you want to create that resource in the management console, and you will see pretty much that's what I'm saying, whatever you picked when you are creating the resource in the management console, that is the exact same thing you go pick in Terraform. I mean, there might be a little, Terraform might make it easier to create in some ways, but overall, you guys can just see, I just show you, it's the same structure. So I'm going to, we can now apply our code. So make sure you save your file. I'm going to save it. Then I'm going to open my code in the integrated terminal. I'm going to type Terraform, apply, and press enter. So here you can review the plan. Terraform is going to create 5 resources. It's going to add change 0, destroy 0. So once you review your plan, you're happy with it. It is saying, do you want me to apply it? Type yes and press enter. And it is now applying those resources. And we would just, it won't take that long. There you go. It is done. So if I go in the management console, let me just cancel this. And here, let me filter by my VPC. And you can see in my VPC here, you can see all the 5 security groups that I just created, right? The name that I gave it, dev, nest, db, sg. So if we review all this one by one, the first one we created is the EICE right here. So you can see that does not have any inbound rule, but on the outbound rule, we have SSH on port 22 that is limited to our VPC CIDR block. Then the next one is the application load balancer security group. So the ALB inbound rule, we open port 80 and port 443 from anywhere on the internet. The outbound rule is all traffic. Then the next one is the web server security group, right? So it's this one. You can see the outbound is all traffic and the inbound is HTTP, HTTPS, SSH. The HTTP and HTTPS is limited to the application load balancer security group, and the SSH is limited to the EICE security group. Then the next one is the data migration server, right? You can see the inbound is SSH on port 22 from the EC2 instance connect endpoint security group. Outbound is all traffic. And the last one is the data server. So where is it? DB server, DB security group, this one right here. You can see outbound traffic, all traffic. Inbound, we are opening port 3306, and we are only allowing the data migration server and the web server because those are the only 2 things that needs to access our resource, our database. And that is it for the security group. So do you guys have any question on the security group one? Okay, cool. Let's continue. Who knows, we might be able to finish this today. I'm going to close the terminal. The next resource we will create is the EC2 instance connect endpoint. So in that reference file, I have the EC2 instance connect endpoint here. It's the EICE. So take it, drag it in your Nest app, or you can create a file in your Nest app, call it EICE .tf. Just make sure whatever name you give your file, give it .tf at the end. Then paste your code in there. And this kind of also brings me to the point earlier, right? The reason why I separated, so if we were going by, was it Mr. Abel that asked me? Yeah, I think it was Mr. Abel, but I'm not sure. If I was going by that same logic, or maybe it was Mr. Emmanuel, if I was going by that same logic that we are including everything in our VPC file, our VPC file is just going to get so long, because by that same logic, we can also include our security group in the VPC file. And now we have the security group there. And we can also include this EICE in the VPC file. So I think looking at the code wise is very easy for me to go to my security groups and I just see, okay, these are the security groups that are there. Versus if I have one long file there's just a bunch of code in there. And I think teaching you guys too, I didn't want to overwhelm you guys with a bunch of code in one file, because I feel like when there's like a bunch of script in one thing, you guys get overwhelmed by that, especially if it's the first time you are looking at it. So that's why I'm breaking them up into like piece by piece, right? So you can see for this EC2 instance connect endpoint, we only have just one resource block and we are done. Okay. For the EC2 instance connect endpoint, this is the resource type that you use to create an EC2 instance connect endpoint. And this is the reference name I gave it. The first thing we have to do is specify the subnet that we want to create the EC2 instance connect endpoint in, right? So you can create it in any subnet, any of your private subnet, because we want to create it in the private subnet. For this project, I'm going to create it in my private app subnet EC2. So in my VPC file, right here, I have the private app subnet EC2 here. So we'll copy the resource type and the reference name. You can create it in any of your private subnet, even the data is fine, but I'll just create it in the private app subnet EC2. So I'm going to go back to my EICE file. So for the subnet ID, I'm going to paste it there. I'm going to remove the quotes, add period, then at the end, add another period and type ID. Then the security group we want to attach to it. So anytime you guys see something with a S, it means it's expecting a list. So here we are just going to add first a bracket. Then the security group it is expecting is the security group we created for the EC2 instance connect endpoint. So in our security groups file, this is the security group we created for the EC2 instance connect endpoint. So we'll copy the resource type and the reference name. Once we copy, we'll come back to the EC2 instance connect endpoint file, paste it in here, and remove the quotes here, add period, then at the end, add .id, because that's the attribute it is looking for. Then here, we want to give it a name. So we can follow the same naming convention here. So copy this, and here, for the name tag, we'll paste it here, but just call it project, environment project EICE. So it will be dev nest EC2 instance connect endpoint. And that's all we need to do here. So we'll save our file. Right, this is it. Then we'll open integrated terminal. And we would type Terraform apply. And press enter. So here you can see, according to the plan, it is going to add 1 It's not going to change anything or remove anything. So once you're happy with the plan, type yes and press enter. It is now applying it. So we'll give it some time. And also, while that is going on, if you go in the management console, you can see it there. So if you come here and select endpoint, where's those endpoint in? Endpoint here, you can see that it is creating the EC2 Instance Connect endpoint. The name, dev nest EICE, that's the tag name we gave it, and it is pending. So this kind of like takes a couple of minutes to create. So once this is in a stable condition, Terraform will tell you that it has created. The creation is complete, right? So that is it for the EC2 Instance Connect endpoint. Do you guys have any question? So please remember, while Terraform is applying, you don't want to abruptly close your terminal, because if you close your terminal, that's it. It's going to lock your state. You are going to stop the deployment. But when you go back and apply, Terraform is still able to keep track of what it has already created and fix whatever needs to be fixed. But you don't want to abruptly close your terminal. Why are we referring to $sign in variables for name? Oh, so Shuba, right? Why we are referring to the $sign? You're talking about just in general with the where I'm putting the tag names and the names for the security group, or in the security group name, right? Okay. So in the security group name, you can really put is a name, right? You can really put anything you want here. So let's say here you can type the name. You can just type the name like VPC security, EIC security group as a string. But for me, and what I've also seen at work is for the different environment you are deploying to, they like to make the name environment specific, right? So let's say I'm deploying this security group to dev now. I'm not going to keep typing dev nest here, dev nest here, dev nest here, right? What if that environment you want to deploy into another environment that is not dev, right? So what this $sign variable does is it allows you to interpolate, because you know that this is a string. So anytime you have a quote, that is a string. So when you have a string, it is the behavior of it is it wants to make it one word. But what we are doing here with this $sign is we are telling Terraform that in this string you are about to create, I want you to find the value of environment and put it in here, and find the value of project name and put it in here to make my string. Because look what's going to happen. If I remove the $sign, right? You can see the color has changed. That means that this is the name that, no, no, yes, you correct. You see, that's just what I just showed you here. So let me do what you just said. So here, if I type var, just how you have it. So if I type var and I remove the brackets, right? You can already see that here it is creating it as a list, not as a list. It is creating it as a string. So that means when it creates this security group, it is going to call the name exactly what you see here. It is going to call it exactly what you see there, var.environment -var project name. That's exactly what it's going to call it. Okay, cool. I'm glad you got it. Yeah, so Yes, exactly. It helps to complete the string, right? So, but if we say, okay, I'm formulating my string, but I still want to include some dynamic values from my project, like the variable name, the project name, the environment, that's when we use that $sign. That $sign and that bracket allows us to interpolate. What did I do? Okay. Just need to copy this and paste it here. Or maybe I shouldn't save this file. So I'm just going to save it because I already applied it. So let me, yeah. So that $sign allows us to interpolate, meaning that it allows us to get the value of our environment variable and project name variable and use it to form a string. But good question. Yeah. You'll see that a lot at work when they are writing the code. The first time I actually learned this method was at work. So and since I saw it at work, I started including it in my own code as well. You are welcome. So we're still creating the EC2 instance connect endpoint because that one always takes forever to create. So just now it's available, but Terraform probably just needs to sense that, and you can see Terraform is done too. Terraform is done. Perfect. All right. Do you guys have any question before we move on? Cool. So the next resource we are going to create. Yes, Ismail, exactly. That's another way to explain it. It pretty much allows you to create a placeholder for a value that you are going to apply when you are running your Terraform appliance. So yeah, it's a placeholder. All right. So the next resource we are going to create is our secret manager. So here we will use Terraform. I'll show you guys how you can use Terraform to pull your secrets from secret manager and still use it in your Terraform code as a secret. So this is the safe way. So anytime you are tasked with something at work, to integrate secret manager, this is exactly how you do it. So in our reference file, there is the secrets manager file. So you can either create your own file, call it whatever you want to call it, copy whatever is in the secret manager file, or you can take the secrets manager file, drag it here, and drop it in there. So you have your secrets manager file there. You can see it is a small piece of code. And again, we are now revisiting data source again. I mentioned it earlier. We are now saying it again here. So in this secret manager file, right? What we have here is, remember, we already created our secret. So if I go in the management console and I go to secrets manager, right? We already created our secret last week. I think it's this one. We created our secrets last week, right? And if I show you here in the secrets, we have just pretty much information for our RDS that we want to use for username, password, and so on, right? So the secret exists already. Remember what I was telling you guys earlier, that you can use data source to pull a resource that already exists in your AWS account. It could exist in AWS. You guys saw with the availability zone, that one we were pulling something that exists in AWS. We are pulling a list of availability zones in the region. You can also use data source to pull a resource that already exists in your AWS account. So here, to pull a secret that already exists in your AWS account, this is the data source type you will use to pull it. And all these things, to find it, all you have to do is type it in Google, right? The first thing is just knowing what you are trying to do. So here, if I looking for stuff on site, I can just say data source. You know, you are trying to pull a data that already exists. So you start with data. You can type Terraform data secrets manager, right? Type something like that, right? So here you can see what's coming up. So I'll click this one, this data source. So you can see here different ways you can use data source to pull a secret. If you want to pull a secret by the ARN, right? This is what you'll use. If you want to pull a secret by the name, this is what you use. I believe this is what we are using, right? Right? But this one also has the secret version, and I can find that for you. But even if you don't want to use the one that I use, you can use this one too, and it will still work the same way, right? Or you can see the secret version here. So retrieves metadata information about secrets manager. To retrieve a secret value, see the AWS version data source, right? Secrets manager. So that's where I got this from, right? So this is probably just referencing the secrets, but this is saying specifically to retrieve the secret value. So that means that the values that are in the secrets, we want to retrieve it. It says, see this. That's where I got it from, right? So I'm telling you, everything that we are doing here, I didn't come up with it by myself. So this is why I'm saying like Terraform is not really writing code. It's more of scripting. You're just pretty much finding information from the documentation and using it. So that's where we got this from, right? So for the secret ID, we just need to enter the name of the secret. So anytime you see secret ID, that is also referring to the name of the secret. Guys, please give me a second. I'll be right back. Okay, sorry about that. So for this data source, right? This data source is going to pull the secret. We're going to reference the secret in secrets manager. Then we can now use whatever the values there in our Terraform code. So here we have the secret ID, and I believe I have a variable for it. So that way you guys can dynamically change it later on. So in that variables.tfl, so after the VPC on line 58, there's the variables for to enter your secrets name. So you can copy that variable. Sorry, this is something is always annoying, it's always in the way. So you can copy that variable. Once you copy that variable, you'll come in your own variables.tfl. Let me close it. And down here, after your VPC variable, paste it there. And for the type, we are going to call it a string. But that's what it's going to expect. Then now we are going to copy this secret name. Once you copy the secret name in your data source, the secret you want to reference is that secret. So we'll type var dot the name of that secret. So now when you pull the secret, right? So when you pull the secret, this is how the secret is going to show up in your Terraform. When you pull the secrets, this is how the secret is going to show up, like this. It's going to show up as a JSON file, as a JSON plain text, right? You can use this in your Terraform like this because you need to now tell Terraform this is a JSON. So when you see this, I want you to get the value of username, the value of password, the value of DB name. That is what this next local is doing. And how you would do that is you enter it like this. So for the secrets, it will be equals to JSON, JS, ON, JSON decode, because you are saying like you're going to get a JSON file, you want to decode it, so you can select that, and it is going to be a parenthesis, right? So you will now copy this here, the data source. We want to decode whatever value we get from this, so paste it here. And remember, when you are using data source, this will be dot. Remove the quote, add a period. Remove the quote here, add a period. And at the end, after the secrets, it is going to be dot secrets, secret. I hope I'm spelling that right. Secrets, yeah, string, underscore string. I think Terraform is trying to complete it for me. Let me select it. Yeah. So this is what you need to have there. So remember, when you pull the secrets value, it is going to come in a JSON. So here with this local, we are saying decode it. And this is what we will decode pretty much whatever we get here to get each strings from the JSON, right? So that's what this is. And once we create our RDS, I'll show you guys exactly how to use it. But this is how you pull your secrets from Secrets Manager, just like this. So I'm going to save the file. And let's just create the TF vars for it. So remember, because we have a variable now, we need to enter the value for it. So the value will just be this. So it will be Secrets Manager. You can copy that or you can type it. So it will be whatever the variable name is. In the TFVAS file, I have it there. So you can copy this and we'll go into our TFVAS file. Let's just paste it here. I'm not going to apply it. We're just going to continue because it's not going to show us anything. So here, we'll paste the name. So what we want to do is in double quotes, go to our Secrets Manager, scroll up here, copy your name, your secret's name. Once you copy your secret's name, paste it here. And sometimes it is breaking it, so I'm just going to fix that format. There you go. And that is how we'll pull the secrets. But once we create the RDS next, you guys will see how to use it. So that's the next thing. We are going to create the RDS instance and you guys will see how to use it. Do you guys have any question? All right, cool.
So Azeez, I have a question.
Yeah, sure. Go ahead.
So I want to ask you about initially we need to actually make the secrets first in the console and then we can like pull these secrets, or we can make the new ones as well.
Yes, I think it's for your Terraform project, it's just better just make the secret, then you can pull it.
Okay. Okay.
Yeah. So just make the secret. So certain things, and this is kind of like something I struggle with in the beginning because I'm always like being hard-headed to say, you know what, I want to deploy everything with Terraform, right?
Yes.
Certain things is fine not to deploy with Terraform. There's things like your secrets, like is an overkill because like you're deploying it with Terraform. It's just like you're doing this, like you're going to do some extra work that you don't really need to do. And from what I've seen at work, we always just create the secrets beforehand. So whatever secrets we need, we have this vault that has all the secrets. Those things are not done with Terraform, right? Because let's look at it this way. If I write a Terraform code to create a secret, it defeats the purpose of what I'm trying to do. Because I will still have to come here in the tfvars file and put whatever the value of those secrets is. You understand? To apply them.
Yes, I do.
Yeah,
Okay.
so it's kind of like I'm sure there are other ways to around it, but I'm just saying it's like an overkill. You don't need to do all that. It's just better just create the secret, then you can use it.
All right. Okay. Thank
Yeah,
you.
no problem. All right. So we are done with secrets manager. The next thing we need to create is the RDS instance. So let's go into our reference file. And first, let's copy the variables for the RDS because I think the RDS has variables. Yeah, the RDS has a lot of variables actually. So you want to copy the variables for the RDS from line 64 to line 93. So copy everything. And we are going to open our own variables file. I'm going to press enter here and paste it here. So here, all these values are going to be, I don't think all of it is string, but yes, all these values are, some of it is a Boolean, but majority of it is a string. So here, right, let's just, for the multi-AZ deployment, that is going to be a Boolean because that is asking, do you want to deploy? That is for when we get the argument in Terraform, the RDS thing, do we want to deploy in a multi-AZ RDS? We can now type either true or false. So the type of this is going to be a bool. So this is like a Boolean. Boolean means the value can only be either true or false. Then for the database instance identifier, this is going to be a string. And like I said, if you don't want to put this restriction on the value that it can accept, the value, you can still limit the value to what AWS wants you to put there. But in Terraform, this type just allows you to restrict the user from entering the wrong value. So, but if you don't want it there, you can remove it and Terraform will still work. But it will work. Terraform can pass it when you apply, but when it gets to AWS, let's say AWS is expecting true or false, and I went and put like something like type something there, is going to fail. So, but it just restricts the user from putting what they are not supposed to put. So instance identifier is going to be a string. Instance class is also going to be a string. Database engine is also going to be a string. And I spelled that wrong. And database engine version is also going to be a string. And the publicly accessible, whether you want your RDS to be publicly accessible, this would be Boolean, true or false. So that's all we need to do for the variables. Just we'll fill that in. Then we can now create our RDS file. So you can create your RDS file in your project, or you can take my RDS file that I provided, drag it into your project. Yeah, and it's there. And these are the things we are going to fill. Okay. The first thing we are going to do here is create the subnet group. Remember when we created the RDS, we created a subnet group. And subnet group is how you tell Terraform. Subnet group in AWS is how you specify which subnets in your VPC you want to use, you want to deploy your RDS in. So it's the same thing here. So here, the resource type to create a subnet group is AWS DB subnet group. And this is the reference name I gave it. The first thing we are going to do here is give it a name. So we can follow our interpolation method we've been using. So let me just copy any of this name here. And in my RDS, I'm just going to paste it here. So it'll be my environment, project, and the name, I'm going to call it subnet group. So here you can just type subnet group. So once you give it a name, it's the subnet IDs. So this is a list of the subnets that you want to allocate for your database. So remember, when you are expecting multiple value, it is going to be a bracket first, then we are going to go in. So first, let me close some of these things so I can show you. So we can open our VPC file next to here. Remember the subnets we are using is going to be the data subnet is the one, private data subnet is the one, and private data subnet is the two. In our VPC, this is where we create private data subnet is the one and private data subnet is the two. So here, we are just going to copy the resource type and the reference name for private data subnet is the one. We would paste it here and remove the quotes, add a period at the end, add another period and type ID. Then you are going to enter comma and space. Then we will copy private data subnet EC2. So select the resource type and reference name, copy it, paste it here, remove the quotes, add a period, and at the end, period ID. And that is that. And next, let me just go into the beginning here. And I can also, let me close this so you guys can see it better. So this is what it will look like. Then the next thing we are going to do is enter the tags. So you can just use the same name for the tag. So once we have the name for the tag, right, this will create our subnet group. Once we create our subnet group, now we can create our RDS instance. This is the resource type to create an RDS instance. This is the reference name I gave it. The first argument is the engine, right? We created a variable for it. So let me just put the variables to the left side so you guys can see. We created a variable for it, right? So for the engine, it is going to be var dot database engine. So I have the database engine here. I'm going to copy this and paste it here. The next one is engine version, right? So this is, the first one is the type of engine our database is going, RDS is going to be, and this is the version of the engine, right? So here, I also created a variable for it. So I'm going to call it var dot engine version. So database engine version. So I'll copy it from here and paste it here. And like I said, for the value of this thing, if you don't want to use variable, you can hard code it. But a lot of the stuff you will see, a lot of values at work, they pretty much always make everything like a variable. And unless if it's something that you really don't need to, like a description, but for most part, a lot of stuff is good to create a variable for it because then you can dynamically change them. All right, so the engine version. So the next one is multi-AZ. So that's if we want to deploy a multi-AZ RDS instance, right? We created a variable for it. So we'll type var. And this is where we call the variable multi-AZ deployment. We'll copy this and paste it here. The instance identifier is the name you want to give the instance. We create a variable for it here. So we'll copy this instance identifier name. And here we type var dot and paste it. The username, now this is where we will enter the username of our RDS, the password, and things like that, right? Remember, that is a secret in Secret Manager, and this is how you reference it. So to reference the secrets, remember we created our Secret Manager here. So this is our Secret Manager. So to reference the username, it will be like this. Remember, we've already got the values for the secret, and we are storing it as a local variable. So now to reference it as a local, yeah, you're going to type local without the S, just local dot secrets right? So the local you guys are saying here is responding to local, but you don't put locals, is just you can have multiple locals in here, but here it will be just local dot the name of the local you are trying to reference, which is this. So we call it secrets, right? That's what you put here. So that's where the secrets come from. Whatever the name you give it, that's what you can call this anything you want. So I call this secret. So that's what I put here. Dot. Remember I told you guys that when we retrieve the secrets from here, it's going to come as a JSON, and that's what we are storing here in this local. So this is what the secret value will look like, right? So now that we are trying to create our RDS username, right? In our secret, our RDS username is called username. This is the key, right? So that's what we are referencing. We're going to reference the key, and it's going to pull the value for us, right? So however it is spelled out in your secret, however you created the secret, whatever the key name is, that what I'm trying to say is that's what you put here. So here it is username, right? So here you're just going to call it secret dot. This something is always in my way. I'm just going to control the username. That's exactly how you do it. And for the password, it is exactly the same thing. It will be local dot the local name where you store the secrets dot when in that secret, this is what it looks like. You want to pull the value of this key. The key in your secret is called password. So you copy exactly how it is, and that is what you paste here. Control V. The next one is database name. We also store that as a secret. So we'll do the same thing, local dot secrets dot the key, whatever you store as the key in the secrets. So we store the key as DB name right here. That's what you copy, and that is what you paste here. Oh, man. Right? Then moving on, instance class, right? We store that as a variable. So let's go back to our variable files here. We store that as a variable. So it will be var dot whatever the variable name is, database instance class. So let's copy it from here and paste it here. Allocated storage, right? This one, we don't have to put any, make it a variable, it's 200. And this is when you are creating the RDS is there. It says 200. So let's put whatever it was there, right? DB subnet group, right? This is the subnet group that you are going to create your RDS in. Remember, we create the subnet group up here. So we are going to copy the resource type and the reference name, and we will paste it here. We'll remove the quotes, add a period, then at the end, add another period. You can see the attribute it wants is the name, right? If you don't know exactly, you can paste this in Google, go to the documentation, look at the attributes, you'll see. So here, the attribute it wants is the name, not the ID. So that's why we have name there. Okay. So the next one is the VPC security group, right? This is the security groups that we will attach to the RDS. So this will be the security groups we create in our security group file. First, we add a bracket. Then let's open our security groups file. Is here. Then I'm going to go to my database security group, wherever I created the database security group, which is the last one. So this is the security group for the RDS. It is the resource type and the reference name. So copy that. We will paste it here. Then we will remove the quotes, period. At the end, we add another period and type ID, right? The next one is the availability zone. What we have already selected the subnet group, right? But we can still select which of the two availability zones we want to create the RDS. It doesn't really matter as much, but that's what we did in the management console. So for the availability zone, remember that one is in our VPC file. So we'll come here, we'll select our VPC file, right? And in our VPC file, remember we are using anywhere we created our subnet, right? So let me come here. So where we created our subnets here, we are using 0 for availability zone 1, 0 for availability zone 2. So it doesn't matter which one you pick. So I'm going to pick my first availability zone, the value, which is that one. So that's what I'm going to paste here, availability zone. Right, so I'm just saying I'm picking the first availability zone. Then the next one is skip final snapshot. This is for like when you are deleting your RDS, when Terraform is destroying. Because what will happen is every time you destroy, let's say you use Terraform to create and you destroy, it would always create a snapshot for you. So if you keep applying and destroying, there will be just snapshot in your AWS account. So this is saying skip final snapshot will just say true because we don't want to keep, especially when you are testing, you don't want to keep creating snapshot when you run destroy. So we'll type that as true. And publicly accessible, right? We created a variable for it here. So we'll just say var dot the variable name, which is this. Copy, and we paste it here. And that is that. We are going to save. And that is everything here. But I'm going to make sure I save all my work because I need to save my variables too, right? So I've saved my variable. I think I deleted something here. So you guys can see there's still error in my code here. There's still error in my code here. It's because I'm missing, I think when I was doing something, Oh, yeah, I have the quote. So, yeah. Make sure you remove the quotes, right? So, yeah, that's what I have. I had the typo of the quotes there. So make sure you remove the quote. And things that are supposed to line up, you can see how all the variables reference line up in the same color. All the string reference line up in the same color. So if you are seeing something like this that don't line up in the same color as the rest, sometimes it won't line up, or you are seeing that red thing here, or you are seeing your file is showing red here, it's showing you that you have an error somewhere in there. So that's how I realized that. So I'm going to save all. The only thing we need to do now is enter the values for these variables. So these variables here for the RDS, we are going to enter the values for it. So in the reference file, the Terraform file, we can copy the variables for the RDS. So copy the variables. And we will open our own TFVAS file. Press enter here and paste it there. So here we are just going to enter the values, right? The value is multi-AZ deployment. We don't want that to have a multi-AZ, so we'll type false. But in the future, if you want to do multi-AZ, you just come and change this to true. The instance identifier name, we'll give it a name. We can call it, is a string, so we'll call it app.db. You can give it any name you want, right? The database instance type, what type of instance type do we want to use? The one we've been using, that is the default smallest one we can use, is the db.t3.micro. And this is all in the, if I go and create the RDS, you guys will see all that stuff there. So that's where I'm getting all these things from. For example, let me just show you real quick. Yeah, we create RDS, right? And you select database instance here, create database instance, right? MySQL, you can see engine version, right? Engine version, a lot of the database username and password, a lot of those things you will see me entering here, right? This is where they come from. So whatever setting you were picking here when you created the RDS, that's exactly what we are doing in Terraform. Any other default one, we don't have to include them. So the instance class is dbt3. The engine we are using is MySQL. So here, in quotes, you type MySQL, lowercase, not capital case, lowercase, MySQL. Then the engine version, right? The engine version comes from here. Once you select MySQL, right here, you can see the engine version. So the current engine version is 8.0.43, right? So here you can enter in quotes 8.0.43. Then publicly accessible, we don't want it to be publicly accessible. So for that one, we can type false. And that is it for the RDS. We are done. So we have our values for our variables and we have the RDS. We can save. Now we will open our integrated terminal. So I'm just so you guys can see that. Open our integrated terminal. We type Terraform. Apply. Press enter. So you can see it has run the Terraform plan. It is going to add two things. It's not going to change anything or remove anything. You can see the things it's going to add: my subnet group and my RDS. So once we add that, we're going to type Y for yes. And there you go. It's now creating the RDS. In the meantime, do you guys have any question? Because that will probably take a couple of minutes to create. Any question on that? Okay, cool. If we look in the management console, right? Let me just cancel here. You can see an RDS is being created. You probably don't have too much information now, right? If we go to the configuration, you can see the name, the database name. You guys see this name came straight from the secrets manager, right? Because that is what we called it in secrets manager. So that's where you can see. So that's telling you that Terraform is that's the word I'm looking for. Terraform is accurately pulling the values from secrets manager and using it within your code. So you can see here for our admin, our username, it is admin. You can see that here. The password, obviously, we're not going to see the password. So, but seeing these two, we know we are pulling our data from secrets manager correctly. And we are not exposing anything in Terraform. So everything is dynamically pulled. This is how it should be done security-wise. So that's that. It will take time to create the RDS. So if you guys have any question, please ask. Oh, thank you, John. Yeah, I don't I mean if you guys want, I can probably create a Telegram channel, but I think maybe I would think about doing that. But the thing about me is like sometimes I'm always kind of like busy. Can we create yeah, sometimes I'm always like busy, but I can create a channel there where you guys can interact with each other. If you guys want. I think that would be good because I see a lot of people always create Telegram channel these days. So I'll look into it, John. So maybe I'll do that. And thank you for the feedback. I appreciate it. As long as you guys are learning, it makes me happy. Can we create secrets using Terraform and refer to it? Yeah, it was the same thing. Yes, I'm pretty sure you can, but I think it would just be an overkill because you will still have to set up some other configuration not to expose your secrets. Because let's say you are using Terraform to create your secrets, you still have to tell Terraform the value of the secrets. Because for example, if you enter the key, you still have to tell it what the value of the key is. So all that stuff, doing all that stuff in Terraform is still kind of like defeating the purpose. All right. So I'm trying to start learning AWS from a beginner level and came across your content, which I found very clear and practical. Thank you. I want to ask if you could recommend which of your playlists will be best suited for anyone starting out from scratch, while also helping me with interview and preparations. Oh, can you see my secrets? Right here. This is what the secrets look like. So you guys, you know the projects we are doing now, all these projects, I've actually started recording them again, kind of like how it is set up on my site where it is just like straight to the point showing you guys all that stuff, right? So once it is done, I'm going to post it. It's not going to be like publicly accessible. It's just going to be on my site. And on YouTube, it's probably going to be for like people that have like that membership thing. But it's going to be pretty much exactly what we are doing, but straight to the point. I think those videos, they're like 2-3 minutes long. It's very straightforward to just show you how to deploy everything. So Shuba, once that is done, by the time you get to the project, you will be able to follow those. So I think I have a playlist on my site. can you please send me an email here just to remind me? And later on, I'll find the playlist for you and I'll send it to you. I'll send it to you which one you should take, like how to follow it. So, info. Yeah, you can email me there just to remind me, and I would send you the in what order you should take them. But if you are just trying to start now, I'll say take the cloud practitioner course first. If you are brand new and you don't know anything you are doing, take the cloud practitioner course. That's where you should start. Then once you are done with the cloud practitioner, take the solutions architect course. Then from there you can start the hands-on project. Okay. Yeah. So the cloud practitioner and solutions architect is part of my project, part of my content, because my content is more of doing hands-on project. But in order for you to be able to do this project, you have to get the practical knowledge. I feel like other people are better at explaining those practical than I can, and I don't even have the patience to record all practical explain stuff. I like just showing you guys how to do something. So that's why I recommend watching those practical one first. Then once you do that, that's just like 10% of what you have to do. The rest of it, the 90% will still be my content. So, but yeah, once we connect, I'll show you that stuff. Okay. RDS is done, and I already showed you guys in the management console that it is here. One database, it is available. We are done. So let's move on. The next resource we are going to create is the IAM role that our EC2 instance is going to use to pull the files from S3. Yeah, the IAM role that our EC2 instance will use to pull the file from S3. So that's what we are going to create next. So here, I'm going to close the terminal. In our reference file, we have the EC2 profile role here. So you can take that one, drag and drop it in your Nest app, or you can create a Nest app and put that information in there. Copy, paste the code and put it in there. So this is what we need. So again, to create an IAM role, this is the resource type Terraform provides, and reference name you want to give it. So this IAM role, we are creating a role that is going to give us access to S3. Remember when we created the role in the management console? So now we are creating it with Terraform. So for the role name, we can follow the same naming convention we've been using. The security group, right? I'm just going to copy this that has the resource type and the reference name. I mean, the project and the environment. I'll copy that. And I come to my EC2 profile. For the first argument, I'll paste that here. Then I can just modify it. So this is going to be an IAM role. So I call it role, -role, S3, full access. S3 full access, right? So that's going to be the name. So the assume part you guys are saying here, and I can show you guys, right, is when you are creating an IAM role, let's just even see if I have any role here. Let me see if I have any role. Okay, the role we created, this is a role we created, right, already. Remember the role as a policy? You see under trusted relationship, right? Under trusted relationship is where you have what can assume the role. You can see here, STS, the service is EC2, effect is allow, right? This trusted relationship, right, part, this is equivalent to this part in Terraform, right? So you can see it's that JSON, it's JSON, so it's already in JSON and decoding it, right? So for the version here, we can put 2012. So in as a string, right? Enter it like this, 2012, 2012 -10 -17, right? Put that, right? Then we have this bracket here. Action is going to be STS assume role. So it's pretty much the same thing you are seeing here, STS assume role. I can't copy anything from here. Okay, I'm just going to do Control C to copy it. STS assume role. That's what you are going to put under actions in double quotes, right? Paste that the STS assume role. Effect is allow in double quotes, allow with a capital A. I should have just left this part here for you guys and just explained it. But make sure you type it exactly how you see it here. The version, STS assume role, effect is allow, and the principal is EC2 service. Same thing you see here, ec2.com. So yeah, I'm just going to copy this and under service here, double quotes and paste it there. Okay, I have two quotes, so let me just remove. Right. So it should be ec2.aws amazonaws.com. So the same thing we see there. So this part is the trusted part that I just showed you. So that's all we need to do to create the IAM role. So once we create the IAM role, remember the IAM as a policy. So here is AWS IAM role policy attachment, right? So this is how we attach a policy to the IAM role we just created, right? So here it is saying, the argument is saying, what role do we want to attach the policy to? It is this role we just created here. So we are going to copy this role, reference resource type and the reference name, copy it, paste it here, and remove the double quotes, enter a period, then come to the end, add another period, and it is going to be the name. It is the name of the role you want to reference. Then policy ARN, this is going to be the ARN of the policy we want to attach to that role, right? So if we go back to this, right, you can see under permission, we have policy here. This is the policy we are using, Amazon S3 full access. It is an AWS managed policy. You can see the policy, if you select it, it has an ARN, you can click it. So let's say you don't even have a row in your account you want to see here. So you can just come to IAM, select policies here, and select S3, type S3 here. And you see S3 full access selected, it will bring you to the same page. So you see the ARN here, copy this ARN, and because it's an AWS managed policy. So you don't really need to do much. You just copy that ARN, add double quotes, and paste it in there. That's all you need to do. So we've created the role, we've created the policy we want to attach to it. Now we are going to create an instance profile. So this is something that when you are creating it in the management console, AWS automatically creates it behind the scene. But when you are using Terraform, you have to create the instance profile yourself. So this is how it would now attach this role to the EC2. So to create the EC2 instance profile, this is the resource type and the reference name I gave it, right? So the first is the name we want to give the profile, right? We just call it a name, so we can use the same concept here. So we'll copy that and paste it here. Then it is going to be dev, and here, let's just call it instance profile, because that's what it is. Instance hyphen profile. So once we give it the name, then this instance profile, what role do we want to attach to it? Right, the role we want to attach to it is the same role we created up here, right, that we are referencing here. So we can just copy that role name here. As you can see, it's the same thing, role. We can copy it here. And we'll paste it here. And that's it, we are done. This is how we create the role that we will attach to the EC2 instance. So we don't need to apply this now. We'll just move on, then move on to the next one. The next resource we are going to create is the next resource. So there's still like a couple of more things we will create before we finally get to the EC2. So the next resource we are going to create is we are going to register our certificates. So I'll show you guys how to use Terraform to register your certificate in Certificate Manager, right? So that's the next one we are going to create. So in our reference file, there's like an ACM file there. Where is it at? Why can't I see it now? I don't know why my eyes is not seeing it. Okay, maybe it's down here somewhere. Secrets Manager. Hold on, let me see. Maybe I'm calling it something else and I'm not. ACM. I'm supposed to call it. I called it ACM, but was, oh no, I need to scroll up. I'm sorry. It's right. ACM. So this is the file, right? So I'm going to take the file here, drag it here, and I believe it has a variable. So let's open the variables file. It doesn't. It does not have a variable. Okay, that's cool. All right, it does not have a variable. So this is the ACM file. I mean, it should have a variable. Hold on.
Let's have a variable is right here.
Yeah, I think I'm just probably selecting it. What did you say?
I think it has
It has a
ACM.
variable. I just have it here. Yeah, I didn't have it in the right order. Yeah, sorry. You know what? I think I was looking at my notes here. Oh no. There's a couple of things we can create first. We can either create the ACM, or we can create the. You know what? Let's create the data migrate EC2. I think I have, because in the order that I have these variables, right? That's how we're supposed to create it. So let me see what I have here for the variable. So after the RDS here, we can create the EC2 now. So let's let's create our data migrate thing. So I'm going to delete this ACM for now. And we are going to create the EC2. So here in our variables file, everything under the EC2, I'm going to copy everything under the EC2. Right, just to right here. So then the ACM is after the EC2. So copy everything here. And we're going to just paste it here on the, right. So let's just fill it out. The AMI variable, that's going to be a string. Instance type, that is going to be a string. Flyway version, that is going to be a string. And the SQL script URI, that's going to be a string. Yeah, so that's all the stuff we need, right? So I'm going to close this for now. I'll close some of this. Then we are going to take the one we want is the one that says the data migrate server. The data migrate server, you want to drag that here. Right. And another thing you want to drag here is this script here. So the data migrate sh script, you want to also drag it here. So let's just go over the script, right? The script, there is no, I've made it dynamic where there's nothing you need to change here. It will work in anybody's environment. So it's the same script we use to migrate our data into RDS in project 2, right? So we are going to, when our EC2 instance launch, the idea is what's going to happen is Terraform is going to run this script, and I'll show you guys where we put it. Because remember this script, we can run it as a user data. So we'll launch the EC2 instance and we will run this script as a user data. So it will update our EC2 instance, change to the home directory, download Flyway, create the SQL directory, download the file from S3, and run Flyway migrate. So the same thing we've done before, right? So this is our migrating script. So that's what that is. So here, this is the resource type to launch an EC2 instance. Remember, it's the same thing we did in the management console. We launch an EC2 instance, then we now we launch an EC2 instance, and we launch an EC2 instance, and we now put the necessary information for the EC2 instance, then we now migrate our stuff. So that's what you guys are seeing here. So this is the resource type to launch an EC2 instance, and this is the reference name that I gave it, right? The first argument here is the AMI. Just like when you go and launch your EC2 instance, one of the first things you see is what AMI are you trying to use, right? So let's we'll do it this way because I think we have a variable for it. So here we have a variable for it, the AMI ID. So we'll copy the variable name. And here we are going to type var dot the variable name. Pretty straightforward. Then the next thing is the instance type. We have a variable for it, so we can copy it. And here we are going to type var dot that, the variable name, which is what we are using for instance type, right? The next thing we are going to do is enter the subnet that we are going to launch this data migrate server in, right? So we can launch it in any of our private app subnet, right? So remember we created our private app subnet in our VPC. So if I open the VPC here and look for where we created the private app subnet. So here we created private app subnet easy1, private app subnet easy2. You can use any of the two. So I'm going to launch it in the private app subnet EC1. So I'll copy this and I'm going to paste it here. So for those of you that actually bought the course on my website, I do apologize for putting you guys through all that stress of, I know this RDS, a lot of you guys had this question for the longest time. How do I do all my migration with the RDS without having to use my snapshot? So now I finally get to show you guys how to do that. So here is going to be this resource type dot reference name dot ID. So here we are launching it in the private app subnet EC1. Then the security groups, right? We have to put a bracket. And remember, we created a security group for it. That's the data migrate security group. So I'm going to open my security groups file. Let me close this so you can see it here. We're going to look for the resource that is creating my data migrate security group. This is it. Some part of this thing, that's why I had the comments there, because when you guys are referencing back and forth, the comments will allow you to see, okay, well, this is where the resource is. So here, we are going to copy the resource type and the reference name, copy it, and we are going to paste it here. And here, we will remove the quotes, add a period, then come all the way to the end, add another period and type ID, right? Then the next thing is we are going to select the instance profile. Remember, we just created the instance profile here. So EC2 row, that is the profile we created, right? So I'm going to close this. Yeah, this is the instance profile. So that will be in this file where we created the profile here. So we'll copy the resource type and the reference name and paste it here. This is how you give your EC2 permission to be able to download something from S3, or when you wanted to give your EC2 any type of access. So this is it. So we're going to put period there and period here, and there it will be in the name, the profile name. So just to show you guys, this is what it looks like. Then we've done that, right? So now this is the user data. You guys know for our script, any script we want to run, we can do the user, we can put the script in the user data. So basically, let me close this. I think we are done with this. So I'm just going to save my files for now. And I'm going to close this variable and open this. So basically, let me put this here. This script, we will run it as a user data. Oh, something I forgot to tell you guys here is that, right, this is the normal script we'll use to migrate our data. But you guys look at what I have here. So this one has like sudo shutdown after 7 minutes. So this one is saying it will shut down. What it would really do is it would stop the EC2 instance after 7 minutes. Because you guys know that we are launching an EC2 instance. We would install Flyway on that EC2 instance, and we use that EC2 instance to migrate the data into our RDS database. That's all we want to use it for. So after we've done that, we want to also terminate that EC2 instance or stop it so it just don't stay there and keep running. So adding this command here would stop the EC2 instance. So pretty much after all these commands have executed, this would now run and it will stop the EC2 instance after 7 minutes. The reason why I have it at 7 minutes is because when you are running your script, you don't want to stop your EC2 instance immediately. You want to give your EC2 instance time for your script to completely execute. And I feel like 7 minutes is good enough time. Then after that, after 7 minutes, it will now stop the EC2 instance. So that's another thing this script does. But the Flyway stuff is stuff you guys already have. You've seen that before. Okay, so now in the user data, this is where this is saying it will run this script, right? And the first thing we are going to do here is we are going to reference the script name, right? What this means is like the user data 64 encode, you guys see that in the user data. So here it is saying template file. So this template file is referring to where our file is, right? So here, after that blue comma, blue parenthesis, we want to enter here where I have that hashtag. We are going to enter something like this. So the first thing you are going to do is that $sign thing we always do. So we're going to enter, I should have probably left that there for you guys. So we are going to enter $sign and the bracket. Remember, it's the curly bracket. In that curly bracket, you are going to type path.module, module, dot module, /. So once you type that, make sure you are outside of the curly bracket, then you type /, right? Then you are going to open this here, copy the name of your script, and make sure the name of the script is exactly how I gave it to you here. Like you can use any name for the script, but make sure you have like the .sh and .tpl at the end. So copy it, copy the full name of the script. And once you copy the name, after that /, you paste it here. And that's all you need to have. So let me just close it. Well, I still want to reference some stuff here. So this is what you need to have. Path module / the name of the script. So what this is saying is that the file I want you to run as a user data is located in the same directory as my Terraform configuration. So that's what that path module is saying. So it's just going to come here. It's going to find the file. That's why we put the same exact name and it is going to run it, right? So you guys now see in this file, we have some environment variable. We have the SQL script URI, right? We have the SQL script URI. We have the SQL script URI. We have the flywheel version. We have those things, right? So this is where we are going to enter it. So what you guys are seeing here, that's what you guys are seeing here. So any environment variable you have in that file, this is how Terraform reference it. So you can see flywheel version. Let me show you. Flywheel version is here. That's what you are seeing here. S3 script URI is here. That's what you are seeing here. Endpoint, that's what you are seeing here. DB name and so on. That's what you guys are seeing here. So you guys get it. So now to reference it, you guys know that the variable we created them as a variable. So let me just put it here and close this. So under the EC2 variables, right? Flywheel version is here. So we are just going to type var dot flywheel version. So copy that variable name and paste it here. S3 URI, SQL script S3 URI is here. We'll copy that. And here we're going to type var dot and paste that. You guys don't mind the color code here because we are putting it in like a user data stuff. The color code will be off, so don't mind it. It will still work. So this is one of the only time you will see not color code like that. Then the endpoint, right? The endpoint we have here, this is how we reference it. That endpoint, we want to get the value. So for example, the flywheel value, we are saying we created a variable, we'll put the flywheel version. The SQL script, we are saying we'll create a variable, we'll put the script, right? But for the RDS endpoint, environment variable that we've specified here, how we are going to get the value is we are going to dynamically get the value from our Terraform resource. Because you know Terraform is creating the RDS, right? So in our RDS, this is where Terraform is creating the RDS. So we're going to copy the resource type and the reference name. Once we copy it, we are going to reference it here, paste it here. Then we are going to remove this, add period, then at the end, add another period, and the value we want to reference is endpoint. So here we are going to type endpoint. Endpoint. Let me just make sure I typed it correctly. Endpoint. Yeah. So we are referencing our RDS endpoint. For the DB username, DB password, for the DB RDS DB name, RDS DB username, and RDS password, it will be the same exact way you did it in your RDS, right? Because you know those values are in Secrets Manager, right? So the same exact way you did it here, right? Your username, you were referencing it by finding it in the secret. So you can just copy the username part here, right? Paste it here. The RDS, so that was, this is, oh no, so let's make sure I'm copying it right. So the first one is the DB name. So you want to copy this one. This is the DB name, right? That's what you want to paste here, right? Then we want to copy the username, right? The username is here. That's what we paste here. And we want to copy the password, get the password from the secrets. The same exact way we get it, did it for the RDS is the same thing you would do for the EC2. So once you've done that, depend on, right? This depend on means that, remember, before we can run this script, right? Our RDS instance needs to exist because that's what we are migrating our data into, right? Terraform, in this scenario, Terraform wouldn't know which one you are trying to create first, right? So in this scenario, we want to migrate our data. In this scenario, we want RDS to be available. Then after that is when we will now migrate our data. So that's why we have to put a depend on here, and we'll say this EC2 instance would depend, before you create this EC2 instance, you must create the RDS. So since this is our RDS resource, we will copy the resource type and the reference name here, and we will paste it here. Then just remove the double quotes and press period there. So remember, you have to have it in a bracket though. So this is telling it that create the RDS instance first before you create the EC2. Because once we create the EC2, we are migrating the data straight. And the last thing we need to enter here is the name, right? So the same naming convention we are using here, we can copy something here like that. And I think I'm done with all this one, so I can close this script. I don't need that. The variables, I don't need that anymore. So here, we'll just paste this here. And we'll call it DB migrate. So instead of here, call it DB underscore hyphen migrate. And that is it. So when we run this now, it should migrate. It should launch the EC2 instance and also migrate the data into the RDS instance for us automatically. And I think you guys had, a lot of people had this question. A lot of people had this question for the longest time. So this is exactly how you do it. So I believe we are done. The only thing we need to do is update our TF-VAS file. So open the TF-VAS file and let's open our Terraform file here. So we can copy everything under EC2. Copy everything under EC2. And no. And here, I'm going to paste it here. So the first thing we need to enter is the AMI, right? To get the AMI, you go in the management console, you launch an EC2 instance. So let's go to EC2. You launch an EC2 instance. So here, just scroll down here. You are using Amazon Linux 2023. The AMI ID is here. Make sure you are in the right region where you are deploying your Terraform code. So, because the AMI is different. The ID of the AMI is different based on the region. So, yeah, we'll copy. We'll copy this. Let me just move this out of the way. So we'll copy the AMI ID, and we would paste it here as a string. The next one is instance type. That's going to be T2 micro, right? Because that's the one we've been using for the EC2. That would be T2 dot micro. T2 dot micro. Then the flyway version, right? I think in one of those files I gave you guys the flyway documentation, right? The flyway documentation. So in the flyway documentation, that's where you guys get the flyway version from. Let me see if I can find it. Let me see if I can find that document for you guys. I mean, you guys have it, it's your project 2 document, but I just want to, because I don't have the flyway link ready. So let me go to project 2 document and I'll get the flyway link. Project 2 details, flyway. Okay, this is the flyway link. Right. I'll send it to you guys so you guys can bookmark it somewhere. So we don't need the ACM file for now. Sorry. Oluwaseun, we don't need the ACM file for now. We'll still create the ACM later on. So remove if you have the ACM file, remove it. Juliet, thank you. I appreciate it. So remove the ACM file from your thing. We are creating the EC2. I think when I had my notes, I think I switched it a little bit, but what we are creating now is what we should be creating, the EC2. I mean, it doesn't matter which one we create first, but let's create the EC2 and migrate our data. So this is the flyway documentation, right? So you can see under the flyway download, like for Linux, right? This is the version. You can see it here. Currently, it is on 11.9, 11.19.1, right? So that's where you get your flyway version from, because you can see this command is exactly what we have in the script. It's exactly here, but I dynamically put the flyway version here so you can always update it, because I think the command always stays constant regardless of what flyway version it is. So that's why I changed the flyway version here. So for the flyway version, we can use whatever they currently have, or the one that I've tested, right, was the previous version. It was like 11.15.0. No, where should I put that? You know what? Let me just use whatever the latest one is. So in case if you guys are watching it in the future, I don't want you guys to be confused. So this is where I got the flyway version from. I'll copy it, right? And I'm going to paste it here. Then the last part is the SQL S3 script. Remember, this is what we did in project 2. We completed this in project 2. So we don't need to upload our script anywhere because we already have it from previous project. So go to S3. right? Once you are in S3, look for that bucket that you've been using for your project. I think it is this one that I've been using, right? Project 2 assets. The SQL script is here. I'm going to select it, and you just copy the URI here. So wherever that, basically wherever this nest file SQL script is in your S3 bucket, just go to that script, copy the URI. Once you copy the URI, that's what you will put here. I think we are time. So once we do this, we are done for the day. I did kind of want to finish, but I won't finish because next week we'll be off. So please remember, next week we'll be off because it's Christmas. You guys go enjoy your holiday. If you have time, practice some of the stuff we've done today catch up to speed. Then when we return, we will finish. We should be done with Terraform project by the next class because I think we are moving at a good pace. So the S3 URI, that's what we put here. And this is all the values we will have, right? So I'm going to save all my work. And this is what the EC2 migrate looks like. Remember, this is equivalent to this here is the user data in the EC2. And the stuff you are seeing here, the environment variables you are seeing here is equivalent to, this is how this will set environment variables in our EC2 to execute the script because our script is using environment variable. Remember when we ran it in our original script, we have export here. But in Terraform, instead of us putting the export, we can just do it like this. Where is it? We can just do it like this. So basically, this part you are seeing is equivalent to if you run export and set your environment variable the way we did it in project 2. So that's what this is. So now let me open the integrated terminal. And I'm going to right click on this and open an integrated terminal. I'm going to type Terraform, apply. No, typo, sorry. Terraform, apply. Okay, it is showing us all the things it would do. Right here, it is going to add 4 things and remove none. And you can see all the things it's going to do. It's going to create the profile, instance profile, and the EC2. So here, I'm going to type yes and press enter. So it is creating the profile. It's creating the profile and is launching the EC2 instance, and it would copy my script into the user data and run it as a user data on my EC2 instance. So basically, if you want to know how to launch an EC2 instance with Terraform and add user data to it to run a script, this is how you do it. And the good thing about this is we are using different things. We have an environment variable in our script. We are also referencing secrets manager in our script. So we are doing a lot with one thing. So it is done, right? So if I go into my management console and I type EC2 here, select EC2 under services. There you go. I have one EC2 running. You can see I call it dev nest db migrate instance, right? It is still initializing, right? You guys know one thing that I learned. And another way is like anytime you run, and some of you guys may know this, but I just actually learned it the other day. When you run user data in your EC2 instance, you guys know that if your script fails, your EC2 instance will still create your EC2 instance. So you won't know whether it executed successfully, your command in your script executed successfully, because your EC2 instance will still come live. It will still show running because the user data failing does not affect the EC2. If it just fails, it will fail quietly in the EC2. but your EC2 instance will still come up. So how we can tell if our script execute is, we can come here and select actions, and we can come into monitor and troubleshoot. Let me refresh. Oh, okay, I didn't select it. So first select your EC2 instance, right? Once you select your EC2 instance, come to actions, monitor and troubleshoot. And which one is it? So get system logs. Is it one of these two? But let me try the system logs. Is it this one or that one? So let's try the system log. Get system logs. Right, it's not that one. So let me go back. I know it's one of them. So I'm gonna go back to the EC2 again. Actions, monitor and troubleshoot, get screenshots. So this, funny enough, this brings us to the same page. So the system logs is here. System logs is here. I think it will come up, right? It's the EC2 instance.
That's
it's
why.
still initializing, exactly. Yeah. So once it is done initializing, right? We will see the.
It's finished. You can try it now. It's finished.
Okay, let me go back. Let me see. Try it again. Actions, monitor. I guess system logs. There you go. That's what I want. So you gotta wait for it to pass the status check, right? So once you pass the status check, you can see it here. And what you are looking for is when you look at this, you can see the output. You know, when we SSH into our EC2 instance and we start downloading stuff, we run in the command, we are seeing the outputs. Those are the outputs you are seeing here. So you can see here in my outputs, I can already see Flyway was downloaded here. So you can see Flyway was downloaded. And if I scroll down, right, let me go back again and see, maybe it would give me more of like the end of it. So maybe that's showing me what was there when I get system logs. So it's cutting off over here. But when I did check it, it was showing me all the way to the end of it. So this might have been because, or let's see, copy system logs. I want to see maybe if I copy it and paste it, maybe it will show me the full log. Or I can download it here. Let's see. So when I downloaded it, it showed up like this. Yeah, so it's still cutting off over there. It's still cutting off over there, which, I mean, it's not bad for what we are trying to. Let me refresh, maybe refresh will. No, yeah, it did cut off. So let's try screenshot to see. No, it's not a screenshot. It should be here. So basically what I was trying to show you guys, let's say this was showing me the logs all the way to the end, right? What I want to see at the end is that my Flyway, at the end, it will show me that my Flyway did migrate. So you know what may have happened is like maybe on the previous version of Flyway I'm running, right? The files were probably much shorter. But now that I'm using a different version, maybe the files is much file to download. So it's not really showing all the outputs. Let me see. Maybe there's a way I can instance events. But for the fact that you are seeing this here, like that just means like your script executed successfully. I was just trying to see at the end of it, because it would tell us, or at the end of it, it will say Flyway migrate. Oh, you know what I think it may also be? It could be because in my script here, it could also be because in my script, I told it to shut down the EC2 instance after 7 minutes, right? So maybe somehow when that executed, it just stops printing the logs. I don't know, right? But if I comment that out, but at least this gave me the confidence that I know my script executed successfully because I can see that it's downloading Flyway here. And I can't SSH into that EC2 instance because it is going to shut down. So if I try to log into it, I won't be able to log into it. So it's still on now, but eventually you guys will see it will shut down. And if it did shut down, then we can also have the confidence to say our script executed successfully. Because after 7 minutes, it should shut down. And how you can test whether it executed is if I try to connect to it, right? With my EC2 instance connect endpoint. With my EC2 instance connect endpoint, right? And I click connect. You can see I can connect to it. That's because it's already going to shut it down, but the shutdown has not happened yet, but it will shut down. I mean, it will be stopped. So that's why I can connect to it. So if we want to properly fully test it, maybe when you guys run yours, right? For the first time you run it, just comment out this to stop the EC2 instance. So that way you can fully review the logs of the EC2 instance and see that Flyway did migrate successfully. Then once you confirm that it works, then the next time you run Terraform apply, you can always now turn this on. So that's pretty much it for today. We're going to stop here because we are at time. First time I finally made time on time. So we're going to stop here. Everything looks good. We've launched the RDS instance, and we've also used Terraform to migrate our data directly into the RDS instance without even, now you guys can see we haven't done anything manually, right? So we've done all those things with Terraform.
Quick question.
Yeah.
So that script, can it be classified as automation of your CI or Terraform deployment?
Automation of
they always during interviews they'll say, are you capable of writing scripts to automate your process instead of doing it manually? Like that script you wrote for Flyway is considered, would that be considered like automating a migration process instead of doing it manually, right?
Yes, exactly. Yes, so that is an automation, right? It's not manually done, it's automatically done. In this case, we are doing it with Terraform, yes. And it's the best way I actually found to do it because it is exactly the same thing we did when we completed Project 2, but we are now doing it with Terraform. The same exact thing. In Terraform, we launch an EC2 instance. We paste our script in the EC2 instance as a user data, and now we which handle the migration process for us. So yes, it is automation. So we are pretty much done. And that's what I wanted to show you. You guys can see my EC2 instance is stopped. It's no longer on the instance running. I don't have any instance running. If I remove this filter, you can see that EC2 instance is stopped. What I found is it will stop it. It wouldn't terminate it, but it will stop it. But it still works. Because now if we run Terraform destroy, it will destroy everything, including this EC2 instance. Then the next time we run Terraform apply, it would apply it and migrate our EC2 instance again, right? It will migrate the data into our EC2 instance. And one of the benefits of it being stopped is like, let's say now I create other codes. When we write the ACM code and the other Terraform code and we run Terraform apply, it is not going to run the migrate anymore. It is only just going to do it that one time and it's done. So everything works the way we want it to work. All right.
Can you hear me? Can you hear me?
Yes, I can hear you.
Okay, I want you to go to your script. I want to see because it looks short to me. I don't know whether you told it to put from GitHub.
Yeah. my script is right here. Let me close this. Right here. So I think I know what you're saying, right? I can open project 2. Let me open project 2. So in project 2, this is what our script looks like, right? So this is what our script looks like in project 2. And this is what it looks like in Terraform. In project 2, we are exporting the environment, we are setting the environment variable. But remember now in Terraform, we set the environment variable using this. So therefore, you don't need to have this on your script. So that's why this got removed. This part is only verifying that this part was set. So automatically these two parts gets removed, right? The third part of the script is where we are pulling our secrets from Secret Manager. We're already doing that with Terraform with this file here. So therefore, this part gets removed. So that's how all these 3 sections got eliminated, right? Then now that leaves us with this section, which is exactly the same. You understand? So you can see sudo update EC2 download flyway SQL URI. Here I just modified the name a little bit, but it's still it's the same concept, right? Just different name, right? That and flyway migrate, and I only add this command at the end to terminate, to stop the EC2 instance, right? Do you understand?
Okay.
Yeah. So it's still the same exact script, because since we are doing with Terraform, we are not going to need this because we're already using Terraform to pull the secrets, and we are using Terraform to set the environment variable. So we don't need this part. So we only need this part. That's why. All right. Do you guys have any other question?
Hello, Azeez, can you hear me?
Yes, I can hear you.
Azeez, I completed the project of Kubernetes and Amazon EKS. One of my friend got hired. He got hired in a company because he completed a project and the project of and the architecture of the project I want to share with you. Can I share my screen?
Yeah, sure.
He completed this project, Azeez. Can you tell me which he did? Basically, he deployed the Netflix clone app. He added security checks like SonarQube, SonarGate. First, he deployed using Docker, and then he deployed it using Kubernetes. Built a CI/CD pipeline like hello, Azeez.
Yeah, I'm listening to you.
Listening. Build a CI/CD pipeline, Argo CD around it, monitoring tools like Prometheus and Grafana.
Okay. So what was your question?
I just I want to replicate it. I want to deploy it like he did.
Okay.
So can you tell me about how can I some tips?
All right. So he's using a lot of service here. So first you just have to know what you are trying to deploy, right? So because each of
Yes.
those buttons you are seeing is like different jobs. So for like he's using Jenkins. Like I don't teach Jenkins, right? So when we do CI/CD, we use GitHub Actions, right? So
Okay.
so pretty much since he's using Jenkins, all the different tabs you are seeing that is doing different things, install dependencies, those are just different jobs that are running. So the jobs are going in the order that is showed it, right? First is checking his code out of GitHub, then is analyzing the code with SonarQube. So that means you have to have experience with SonarQube, how to probably use SonarQube to analyze your code. Once it passed, it is now still using SonarQube to check the quality of the code. Then from there is installing the dependencies, right? Right.
Okay.
It is installing the dependencies in that install dependencies. So whatever in this Jenkins area, whatever is using there is installing the dependencies in the area. Then the next one after it is just checking the dependencies, right? Then from there, it has some type of trivia files, whatever that means. Maybe that's how he's building his image, right? Then once it push and build, no. So he has the trivia file. I'm not sure what that job is doing. But then once that is done, he's pushing his image in that Docker part, Docker push, right? Then the trivia
Okay.
image scan. So okay, so it looks like that trivia thing does scan your image. So once you build,
The scanning the image. That tree is
yeah.
just scanning the image.
So once you build the image, the trivia is scanning it, right? So once you scan it, it is deploying it into a Docker container, right?
Okay.
Then from there, from when you build it to, it has like the other part with the Prometheus. I don't have experience with Prometheus and so I think that's the part is deploying with Kubernetes. So two ways is deploying it. So there's part is deploying with just deploying the Docker container, right? That's the first part, which connects to the email notification and deploying the app. Then the other way is deploying it is deploying it through Kubernetes, which the part he has there is like he's installing Helm and Algo, the Algo, and is pretty much those part I'm not sure. Then he's deploying his cluster. I mean, this is like this is well thought out and very detail oriented. So I wouldn't deploy mine with Jenkins because I don't even have no Jenkins experience, right? But we can
Okay.
you can still replicate some of this stuff he's doing, and you can even probably limit some of this stuff like so basically the gist is you're checking out your code. Once you check out your code, you are scanning the code, right? Whatever the code you're about to run, you are scanning for the quality of the code. So he's using SonarQube there. You can think of, let's say you choose to use GitHub Actions, you can find something in GitHub Actions that first scan the code. So that's a job. So once you scan the code, right, you
Okay.
install the dependencies in your environment. So with GitHub Actions, GitHub will provide the container to you, right? So the container will only come with whatever basic thing is there, just like how you get an EC2 and it's basic. So if you need Node.js dependencies, right, then you have to install the dependencies on it before you can now start building your thing. So that's what he's doing there. So you can do similar thing with you can do similar things with GitHub Actions, but you also need the code is deploying. So you see that website he has deploy at the end. Do you have the website? Do you have like the application itself?
Okay.
So you will still need the website, right? Because that's what is deploying. So when it checks out the code from GitHub, that is what is checking out, that deployed website. Then is scanning the code. Once it scans the code, is installing. It looks like it's some type of Node.js application, is installing the dependencies for Node.js. Then he builds the image, deploys it using Docker, ECS. I mean Docker, then it also deploys it. Then he also deploys it using Kubernetes.
Yeah.
So I think we can do similar with our project. It's definitely at the end when we do the CI/CD, it is something similar, but ours is only going to be deploying to ECS, not Kubernetes. But you can take the same concept. If you want to take it further and deploy to Kubernetes, you can do that as well.
Okay. Is there any project of yours similar to this, like GitHub Action project,
Yes.
or
Yes, the GitHub Actions project we have is similar to this, but in that GitHub Actions project, we are deploying to, so here it looks like it's just deploying to like probably like an open source Kubernetes, right? But in our project, yeah, the CI/CD project, we will be deploying to ECS, and we will be, and if you want to do it to Kubernetes, you can do the same thing as well. And my CI/CD project also uses Terraform. So a lot of the infrastructure in AWS will be built with Terraform. So, I mean, it's something you just have to gain experience in some of those things he's done to.
I showed him.
I
Yes.
think, can I jump in?
Yes, I showed him my Kubernetes project. Yes, please.
Yeah. So I think what the biggest thing in from what I'm saying is that he, like you said, he deployed it manually, but the biggest thing is he was able to add Argo CD and Helm, which helps manage Kubernetes clusters. And that's
Yes.
why he is able to say he's capable of doing the same thing or working for Netflix. You understand? Because now he can manage clusters. He can go deeper with that Argo CD, where you're telling the clusters, like if you have clusters, a CDN, what they call CDN, in different AZ zones. That Argo CD is what helps you manage those clusters. That's why you see after Helm and Argo CD, it goes back next to Kubernetes to deploy in that EKS. Then from there, you see next Prometheus and Grafana for monitoring. Then it ends to the deployment of the websites. That's where the users are able to access what he has deployed in different availability zones. And that's like that's now you're talking, I am enterprise capable of doing a deployment where is I can clone my deployment to different enterprise, manage it, and deploy it to the users. So I think, like you were saying, the biggest, like Azeez was saying, he can do almost all the same things. But this Argo CD and Helm, from what the little I know about it, is able to manage clusters in a multi-range. There's Helm, there's another one called EC2. They are different similar tools, and they are not very hard to it's like Prometheus and Grafana. They are not very hard. You can use a YouTube video and understand it. And that's how I've done the same thing. I've done interviews on it. And once you get the hint of it, it's just like an add-on. If you understand the architecture of a Kubernetes, It's just what that under the worker node is one of those add-ons you put under the worker node that helps you manage your clusters from a master to a worker node. And from there, you can monitor what's actually going on inside the pods, like Aziz was talking about. Then from there, it goes back to the Kubernetes. And that's why you see that connection at the end, the last 3 dots on the end, from the container down to the Argo and the Helm, then goes back to the Kubernetes. Then Prometheus and Grafana is just another added step for monitoring it, like how Aziz just did at the end, using logs and visualization of the graphics. Once you want to see it in a visual perspective, then from there it goes. You can even skip that Prometheus and Grafana, and from Kubernetes it goes straight to deployment. So I think Aziz explained it right. He can do it, and he just did a very good job of creating a very good a diagram of what he did and put projects with Netflix deployment. By putting all these steps, he's telling the interviewer that he knows what he's doing, and he explained it. And I think with as this end of project, we can do something like that, but it won't be with Jenkins. He's using Jenkins, as I said, who can replicate different tools that we can do a similar project. So there's nothing really out of the ordinary with this.
So for what I'm teaching you guys, I just want to show you guys like the general basics of like just how to get your hands dirty with having like we've done ECS, Kubernetes, stuff like that, right? Then once you do your CI/CD project and you understand that, then you can now start mixing it together, right? So what he's doing here, I mean, yeah, there's a lot of diagrams, but some of it you can even probably simplify. Because if you have like GitHub Actions, there might be an actions that will scan your code for you, the quality of your code that checks. It has to pass something. So so where he has the quality stuff right there, right? And after the checkout, you can do that with GitHub Actions very easy. There's probably like I'm sure there is tools out there in GitHub Actions you can use to do that. Then
Azeez, what if we skip this process? We skip this part, and
which part?
then
Which part?
This part. This part.
Which part?
Docker to
the one
Privy image scan.
No, that part is good because after you build your image, before you push it to you know that part too, you can even do that in ECR. So ECR has like a scanning feature for you that once you push your image there, it scans it, right?
Yes.
So you can now have your job scan, enable the scan part in ECR. Then ECR will respond back to you with a result of the scan, and you can now tell your job based on the result, don't deploy. If the result is there's a vulnerabilities in the image, don't deploy the app, right? So that's pretty much all he's doing on that part, the deploy to Docker, right? So the Trivy part there is scanning the image after he builds it. Then if it fails, then it won't deploy. But if it passed, then it would deploy. And the email notification part is just that is you can also probably do that not probably, you can easily do that with GitHub Actions where you send notification. Once your deployment is successful, then it sends a notification to some notification and the app. So you see the Netflix app you're deploying, right? That's just an application. It's just a Node.js application. It's no difference from the application we are deploying, right? So I can do this project. I mean, will I do it now? No. If we have time, I may work on something like this and show you guys, right? But we do have a similar project at the end, but it is not deploying to Kubernetes. It's only deploying to ECS, right? It's deploying to ECS, so which is kind of like the same thing. Because if you can deploy it to ECS, you can deploy it to Kubernetes too. It will be kind of like similar process. right? So
My
looks like it
friend
is very
told.
well thought out and is a lot on the screen, but it can be simplified with GitHub Actions, and you will still get the same result. And you can still implement a lot of the things they implement. The only part I don't have experience in is the Prometheus part. That
Okay.
yeah.
Okay.
So the
So
Prometheus,
my friend,
monitoring with Prometheus and Grafana. Your
when
line
I
is
showed
cut.
my projects to him, he's my senior, so he told me of many tools like Kubernetes, CI/CD pipelines, Docker. Uh, he told me I am making good progress, but when he showed me this project to encourage me to build a project of 2 to 3 DevOps tools
All right.
like this.
Yeah. So
He
have
also
you
encouraged me to use Terraform.
exactly right? So for example, in
Yes.
our CI/CD project, it does use Terraform, right? Our infrastructure is deployed with Terraform. Then the rest of the part is
Okay.
our image is built and pushed with GitHub Actions, right? I can probably go and review it if you guys want me to put the scanning the quality of the code,
Yeah.
right? Before and after the build, I can add that part there. And that's pretty much all this is here, right? Then the deploy part sends an email notification. I can also add that part, right?
Okay.
And the app is deployed, right? The second part is just like the where you see Helm and all that stuff. That's like the
Okay.
dependencies. Like you have to install Helm is like a Kubernetes package manager. So since he's deploying to Kubernetes, he has to install those things. So if I do it, I'll probably just do it for the ECS part, but I won't do it for the Kubernetes. If we have time, I can do the Kubernetes, but we have similar project. So I think you are making good progress. You just have to be patient to get to the part where you make sure you understand the Terraform, you make sure you understand Docker, and you make sure you understand Kubernetes. Then once you've done that, then do the CI/CD project. Once you do the CI/CD project, this pipeline will make sense to you because in your pipeline,
Okay. Okay.
you can do
I will
similar
change
things.
it. Yes. Yes.
You can in your pipeline, you can do similar things, but you even be using more tools that proves you understand automation. Like it's not using Terraform, so this is more. It's still an automation. It's still like a deployment, but he's using Jenkins, and he's also using. So I don't see any part where he's using like any um, Terraform to to deploy. But based on what I see, it looks like he's just deploying to it's just deploying to like a kind of like an open source thing. And this also leads me to think that he doesn't have this application is showing you here is very good. So that's the thing. I don't want to even get into criticizing it, but I think you should be patient to when you get to the CI/CD part, all these things will make sense. Because from what I'm seeing here, this is not even
Okay.
dynamic. I don't see a database where your data is being migrated in your pipeline. So this looks like just a static website. It looks like it's just a static website. That's it.
Yes. Yes.
This
I
diagram
will
is
share it in the Slack community.
this diagram, like Aziz said, this diagram is like Aziz said, this is very basic. It's not, he's just marketing it by putting the project Netflix deployment and website, but this is very basic. It's not that deep. It's just telling the person that, hey, I know how to deploy using CI/CD from Jenkins, using GitHub to test the SAST and Dast. SAST means static. If it's like Azeez said, if it's a dynamic and it's using a database scanning tool, use Dast. Then that's when you start saying, okay, you're getting deep. Then you're going to deep waters. Then he doesn't show any Dast testing. He just did a SAS testing, and it goes into the containerization of the image and deploys it, and he puts Prometheus and Grafana, which is not that deep. It's not that deep. You're just
So yeah, I think it's good. Like I really don't even want to criticize it. Like I really think it's well thought out, right? But initially when you look at it, it does look overwhelming. But when you take a step back and look at it, it's something you guys can do. You just have to give yourself time to finish all the projects. First, who am I talking to? Like I think he dropped. Did he drop? I think he dropped, right? So what we are saying, that is the accumulation of everything you guys are doing now. In the end, when you guys do your final project, you guys will be working on stuff like that. So, but I like some of the things I see there, like the checking the quality of the code in the beginning, right? Before we even build our image, I like that part. My CI/CD pipeline does not have that. I can include that. Then checking the quality after the image is built, also checking the quality of the image in ECR before we deploy it. I like that part as well. It's something I can also include in my pipeline. Sending the notification email, I like that part as well. It's something AWS has tools like SNS that we can use to push notifications. So it's like a lot of some of those things is like I'm just kind of giving you guys, I don't want to overwhelm you guys with things like Prometheus, Grafana, things like that, because I've been working in all my projects for 8-9 years now and I haven't used any of those things, right? So I really don't want to be introducing that to you guys heavy when I'm trying to teach you guys the basics of things you need to know, right? So once you guys get the basics of everything, then take that knowledge and run with it. You can take my pipeline and look at the image he has and you say, okay, you know what, as this pipeline does not have this, I think I want to add a job to this pipeline that does scan the code before and after I build it. Then you just do that stuff. So I expect you guys to just take the knowledge from here and run with it, because I'm not going to be able to show you guys everything, right? But I like what I saw, and I think I'm going to go back and review some of my pipeline, because my pipeline does not have any type of quality check. I mean, it does the work, right? But I like the quality check that he has in there. I think it's very well thought out.
Yeah.
So I mean, have you done the CI/CD project? I think you're breaking out. So if you haven't done the CI/CD project, I would advise you to be patient until you get to the CI/CD project. Once you get to the CI/CD project, we can do something similar. I don't want to say something better, but we can do something very similar to that project and pretty much enhance whatever CI/CD project we have now. We can enhance it by adding some of those checks to it. And if you want to add notification and all those things, we can do that. So I think you should just be patient till you get to the CI/CD. Anyway, that's pretty much it for today. Please remember there's no class next week. You guys enjoy your holiday, and I'll see you guys on the 3rd. So Merry Christmas to you guys.
Thank you so much, Azeez. Merry Christmas.
I won't see you guys till after New Year. So Happy New Year in advance as well.
Happy New Year. Merry
Azeez.
Christmas.
Merry
Yes,
Christmas,
sir.
everyone.
Happy New Year.
Hello.
Merry Christmas.
Yes, sir.
Can I see you after the class, please?
Okay. Yeah, so you guys enjoy your holiday. if you have time, try it, but it's kind of like a long time. So we have like, that's like almost 2 weeks, right? We are not seeing each other. So try not to not do anything for 2 weeks and then come back here on the third, right? Try to do something in between. Enjoy your holiday, but still work, right? Do something in between. Try to get up to speed with everything we did today. Make sure you understand it. If you have any questions, reach out to me, and then we should be done with this project on the next class, because we only have just a little bit to do. Thank you, Juliet. Merry Christmas. Juliet, Ismail, Merry Christmas, guys. Enjoy your holiday. And I'll see you guys when we get back.
Try calling you in Slack, but I didn't get
Thank
any
you.
response.
Yeah, I think when you called me, I wasn't online. Yeah. So where's the so we're here, John, we're here every Saturday. Every Saturday. At the same time every Saturday, but next Saturday we'll be off because of holiday, and we'll be back on the next one after. I've sent you an email. Okay, I'll check the email and I'll respond to you. Yeah.
Thank you, Azeez. Very happy New Year, and I think we all are looking forward to learn more from you in the upcoming year.
Oh, thank you. Yeah. I started recording some projects. So I do have I think moving forward gonna be like we're going to do some really cool projects moving forward once we get through all these things.
Yes, thank
So
you.
and I'll take the knowledge that I just got from the CI/CD, and I'll try to improve our CI/CD before we get there. So I'll try to add some of those checks things just to make it look more sophisticated. So I think by the time we get there, you guys will be very happy with it. So
You are creating new projects, Aziz?
no, I'm not creating new projects, but I'm pretty much enhancing the one we already have. I mean, I do have like a new project, but depending on how much time we have at the end, I'll see maybe we can do it, or I might just give you guys that project as a final project. It's like a different application. It's the same concept, but the application is written in I think a Node application. It is a Node.js application as well. So maybe you guys can now deploy that Node.js application at the end, right? Then the final project will be you building everything out in CI/CD, implementing Terraform and all that stuff. So I think if you are patient and you just keep going at the rate you are going, all these things will make sense to you at the end. Trust me. Trust me, you'll be able to build a pipeline that is just like your friends, that is even using better tools like Terraform and GitHub Actions.
Inshallah.
Yeah.
So with Marvin and SoniCube, are we doing anything with those or?
No. Like I'm just teaching you guys just strictly like AWS. And when you do use third-party tools, those are tools that like Terraform, very important to learn. Ansible, very important to learn. Those are the kind of ones I'm showing you guys. Like really, you guys don't really need to spend too much time on monitoring, unless if you can do monitoring after you've done everything we are doing here. So now, once we finish the CI/CD project, if you want to now say, okay, you know what, my Kubernetes project, I want to implement Grafana in it, Prometheus or whatever, then go do that. Then you can take the knowledge of what you learn here and build on it. But it's not something I'm going to cover here because I feel like then I'll be spending more time on something that really I haven't used it at work, and I really feel like you kind of have to be on like a security team to use some of these monitoring tools. So I'm not going to focus on it. But I like the checks in the pipeline, and I think I want to implement that in my pipeline as well. Okay. Don't forget to destroy. Oh yeah, thank you, Juliet. Yes. So am I sharing my screen? Yeah. So the thing about this is like now that this environment is done, The good thing about Terraform is all the work I've done today is not lost, right? I can destroy everything. It will clean up my environment back to 0. And when I apply it next time we get back, it would be back to exactly where I left off. So I'm just going to run Terraform, destroy. I think I'm spelling that wrong. So run Terraform destroy, type yes, and now it's destroying everything. It will clean up my environment, my RDS, everything. And next time when we continue, we should be done. Okay, so where were we? All right, well, thank you guys. Once again, happy holidays, and I'll see you guys in 2 weeks. All right, so I'm going to end now. Mr. Wright, I think I'll call you, but I have like 30 minutes. So, Mr. Larry, I'll call you first, then Mr. Wright, I'll call you after. I think Mr. Abel is still there, but I'll try to call you all three of you now, but I don't have much time. But I'll try to call you guys today, right after this meeting. All right. Thank you guys. Bye. I'll talk to you guys later. All right.
Thank you. Bye.
All right.
Thank you, man.
Bye. On YouTube, bye. You guys enjoy your holiday. Those of you in Nigeria, don't play with too much banger. So try to be safe and enjoy yourself. I'll see you guys in January. All right. Bye, Juliet.
Azeez still remember Banga.
Oh yeah. So Banga and less dirty December. Don't dirty December and forget all the stuff you've learned today on. So, but I'll see you guys in January. Have fun. I wish I was in Nigeria though, but have fun. All right. Bye guys.
Bye,
All right.